has been done for Commodore 64, especially computers. We'll be talking about the challenge itself, the rules. We will be summarizing what went good and not really. We will be going through the entire process of choosing the right approach. And we will be also very briefly talking about the design of the LLM module. We will also talk about the near future. So let's start. Marek Zmysłowski here, experienced cybersecurity researcher and co-author of cybersecurity books, you name it. He was everywhere, done everything. Me, a little bit similar. I also have some experience, but today we are talking about Commodore computers. So let's start about my collection. I have over, depending on how you will count them, over 110 working computers. Commodore computers, 8 bits. I have everything. I have a dedicated place to repair them. One of them is very special, since my hobby is electronics in the pretty advanced level. I've purchased a copy of PCB from PCBWay from China, and I populated this mainboard with the best possible parts that I could find on Mauser Electronic, mostly, but in total it cost over 1,000 euro. If the capacitor was available with the certification for an extended period of time and temperature, this was the one I was choosing for this computer. So it will last for another 20 years. Most of these ICs are new. Some of them don't have still replacement, and I didn't go through any shortcuts. So this is board 250-407 with TTLs, no 8701 ICs. So guys, if you will be doing something like this, don't go into HDMI. Just stop being poor and buy better grabber. So a short recap from the past. I presented in Bucharest pen test done by unexpanded Commodore 64, doing stuff with modern systems. So there was cross-site scripting, there was a open relay abuse, there was shell shock. This was actually very fun because Commodore ASCII don't have free chars that were needed to execute shell shock, and I figured it out very late before the conference, so I needed to rush it. But it was done, and it was properly recorded. Here is the network scanner that I also wrote for Commodore 64. It was basically reading banners, and try to log in over Telnet, but it was capable enough. I also have a single video on my YouTube channel where I'm connecting Commodore to the locally hosted LLM at my home. Well, this was a thing 2 years ago. Nobody thought that you can have your own LLM at home. So, why we are doing this? Commodore 64 is a computer that created possibly the best cybersecurity community in the world. There is no comparison to any other machine from this time. This computer already have actually working Bitcoin miner written by Polish guys. It has ported Mario, and the guy who ported it, after 7 years of working, he was sued by the gaming company. You have Commodore 64 working in services still in crankshafts. You have Sonic for Commodore 64. You need to have RAM extension. You have VHS quality video for Commodore 64. You have some kind of Winamp. You have new 3D engines that are still developed, again, by Polish guys, for Commodore 64. Here you have Contiki. This is operating system for memory constrained systems. This is the older version with GUI. The newer version is only terminal only, but it works. And except this, we are working on something else that we will be showcasing soon. Not all went well. There was a YouTuber who knew faster than me that the radio on International Space Station was replaced. So they have again come, and he connected with Commodore 64 to the International Space Station. He was first, but I was better prepared. So this was my equipment. I even made my legal call sign, Sierra Papa 5 Commodore business machine, Charlie Bravo Mike. But he was the first. Everything was prepared on my side. Anyway, the reason why we are talking today is the computers now, they have these dedicated AI modules that you can connect to them and play with the things like YOLO, whatever. You have this for Mac, you have this for PC, and I didn't see anything for Commodore 64, which is obviously the situation we need to address, okay? So the rules of the challenge were, it has to be similar to 80s technology. It can't be like separate big thing that is just lying there, obviously not a part of this computer. It should be compatible with as many Commodore computers as possible. This is not obvious. Remember that these computers at that time had different even connectors, standards, everything within a year. So if you want to have compatibility, you need to usually buy the joystick for this particular machine. So really, even connector for external mass storage devices were different. So yeah, we didn't want to compromise C64 functionality. So we didn't want to overtake the entire computer. There is a dedicated signal for a CPU that will basically disable it, and you can freely access all the stuff on the main board. You can address the memory, see it, VIC, whatever. Should be easily replicable. This is for you guys, and we wanted to create a tool, that's something that is actually working, not proof of concept. This is very important. So Bitcoin miner is fine, but it will solve the block within 300 years. Nice, okay, but something we wanted something more. So we started a research about what was done in the past. This was pretty easy because I have a collection of almost 400 books related to Commodore 64, so I was digging it. But it came out that there is no really coverage of these things in the basic, despite the fact that this computer had a lot of memory at the time. So I've created a machine learning program, and I wanted to showcase it on DEF CON. But the COVID came, and this was actually good for me because later on I found out that there was a guy who made a very similar thing to me in '87 for research, unfortunately. So he did a machine learning with the numbers recognition. My design was a little bit robust because I was using the floppy disk drives who has their own CPU, 6502 and 2K of memory. They were daisy chained. This is again unexpanded Commodore 64. You are just connecting from one floppy to another up to 5. And they can process the information independently from the floppies. So I've basically made a machine learning software that was recognizing these signs, and they were buffered and they were solved on the another disk drive, so it was streamlined like 5 times more. And I was also using a light pen because Commodore 64 have integrated part when it is exactly monitoring the timing of the pixel generated in the real time on the CRT monitor. So yeah, this very nice. Unfortunately, not really known. So will be this a first AI? We think yes. So the question is, do we have resources and knowledge to do this? We will need to have programming skills. That's Marek. And some of the technical hardware expertise. For example, 2 years ago, I believe, we started to poke around scalable corporate type retrieval augmented generation software, but this is not irrelevant right now. Just to let you know that we have some background in programming these things. This is from the times when the models were accepting just up to 2K of tokens at the encoder, so yeah. Anyway, electronics. Do we have the skills? Yes, I have this dedicated place for maintaining all the computers. So yes, I have also a lot of experience with making some smaller parts for Commodore. That's good. It will be useful. And for this challenge, we'll be using the version C, just because it has LumaFix for a little bit better video output. But this is not really important, just to let you know that this is a version from 1986. It looks a little bit different than to what you can use to. There were 2 main Commodore 64 computers in terms of design. There was a third one in New Zealand, of course, in New Zealand. So we had to select the proper interface. Again, we didn't want to overtake the computer. So if we would take expansion port, then, well, we can do everything with this computer. Like, as I told you, we can disable the CPU and use it as electronics that is connected to whatever. This is not the idea. We still want to have functionality. We want to have third-party software loaded. This is out of the question. Especially that many users right now are using some external data sources through this extension. So no, we would be unable to use, for example, Capuano, Ultimate 1541 to whatever. We don't want to. Floppy. This is a good idea. You can transfer the data over this interface. As I told you, I have quite a lot of experience with these things. However, again, some of the external memory is using this port, and this is, well, it would be difficult to daisy chain anything else on top of it. Bad idea. Tape, no, not because we wouldn't be able to control it. You can, differently in the version 1 and version 2 of Commodore 64, but the problem is that many of the devices that you are connecting nowadays to Commodore computer are powered from this port. So this is, again, no. Obviously, the last thing that is for us is the user port. For this port, people usually were connecting the printers. Nowadays, this is basically unused. If you will look at the Gideon logic or whatever, any emulator, they are omitting this port. It's not very popular if you want to have a party and play the game with 4 guys, then yes, you have the extensions for it, and this would be probably the only use case for it. So we have a plan. Now, what we should do, how it should look like. So let's explore the original modems that were connected at the time to this port. This is the originally packed Commodore modem that I've unpacked for the purpose of this talk and for the pictures. So this is how it looked inside. I didn't try to register, but there is an option. You have software, you have everything. It looks really, really nice. We also wanted to have something that is usable again. So these computers, these PCs, these MacBooks, they are using external TPU or GPU, whatever you have. So we wanted to have the same, but we didn't want to have this. We didn't want to have Raspberry Pi. Raspberry Pi is big, chunky. This is not the way to go. So we've collected a lot of computers in order to choose one of them that would be supporting our solution. And it came out that we want, again, something small. So we chose a small computer that is not really known, and it is extremely not user-friendly. You are buying this computer, the first thing you need to do is to flash it like a phone, or you will do nothing with it. So we have chosen Radxa 0 with a lot of RAM, actually. 8 gigabytes will allow us to run a lot of software, bigger models even, and, well, you will see. So we have mini computer chosen. This will be our module, external module. But if we want to make it like a product from 80s, we need to have software delivered with the device. So what we can do? Well, I was considering opening this factory sealed floppies for Commodore, but I said, okay, maybe difficult, maybe I will bring this equipment here, I don't know, so let's move somewhere else. Since we didn't overtake our expansion port, we can have still cartridge available. So we've decided to go with dedicated cartridge. This is Magic Desk. You can download it. You can purchase the copy of this PCB design from any bigger provider. We've programmed it. This is the configuration file. You have here some of the terminal software. This was how the process went. Pretty straightforward. Everyone who is poking around it will know this program. This is a very basic one. So we've printed also the case. For this purpose, we purchased a bamboo printer just for this project, and it stays unused a little bit since then. But we have also a capability to build a case for this cartridge. This is how it looks after completion, and we have a part of the software. Marku.
Testing? Okay. Thanks, Konrad. Before we started, I would like to thank you, the organizer, for inviting us, giving this talk. Second day, first things in the morning, after the after party. Thank you very much. And it's probably not related that we are from Poland and we can survive that. Okay. So as you can see, Konrad is a Commodore freak in this tandem, so I will tell you a little about LLM itself. So as Konrad mentioned at the beginning, we want a tool, not a toy, so we want something that really works, not just a POC. We could run something small. There are different models. Recently, there are even models called like random. So they behave like Llama or other more popular model that does return random characters. So we want something that really works. So we decided to use Tiny Llama in the Instruct version for our purpose that is built on Tiny Llama. But Tiny Llama itself is not very good with a lot of knowledge, and we want, of course, if this is running on Commodore, it needs to ask the questions about the Commodore, right? So what to do with that? So we decided, okay, let's fine tune it. Let's collect some knowledge about Commodore, put inside the model, and see how it works. So can we do that? Well, we've got the power. So we built few quite huge machines for that. We have graphic cards like you see the P40. We have a RTX 3090. We have RTX 3080. So we have enough equipment to fine-tune it. Cool. Now we need some data. Of course, you know Konrad is Commodore freak, so of course he had the 360 Commodore book in PDFs collected from, I don't know when it started, but yes, we do have information, we do have a data, we can put it inside LLM. Cool. But how to do it? Okay, we need to pre-process those books, right? They were quite old. Not every book was easy readable. As far as I remember, some of the book, even though they were in PDF, they were just images included in the PDF, right? So we need to use OCR to get the information, and of course prepare in a special way those information to fine-tune it our model. So how we do it? Of course, we ask ChatGPT to help us. So we took those books, we took chunks of those books and sent to ChatGPT for pre-processing in appropriate format so we can use this. It was working. It cost us a little bit, almost a little more than $250 for using ChatGPT API, but we were managed to create appropriate data set for the fine-tuning. So that was cool, and we failed. We failed because the model was too small, so it was not able to handle all the knowledge that was collected in the book, and the knowledge was very, how to say, like detailed, right? Very technical and very detailed. So there was a lot of information that this model was not able to handle. So we failed that. ChatGPT didn't want to give us money back, so they said, okay, it's our problem. So we need to find something else. So we decided why not to use a RAG. RAG, which is retrieval augmented generations, for those that are not aware. In the simple version of this, it's just a external additional database that contains information, data, that can be used by LLM model, which was cool. Okay, so we decided, let's build RAG. We already had that experience, as Konrad said, we already were doing this locally for our PCs to building RAG with the models. So we have enough knowledge to build something like this. So yeah, let's use these things. Right now, of course, there's more different type of RAGs right now coming up. Every half of a year, someone is creating new one. But we decided to use the easiest one, the simplest one, right? Naive RAG, which requires only LLM model that will do processing and one more model that was used for text embedding, which is additional model that can cooperate with the database itself. So we decided to choose this GIST embedding model for our RAG, and we decided to use this and run this. Okay, so as you can see, that was only my part. It took 2 months, but I got only 6 slides. Thank you.
And again, if you want to create model for a user who is starting LLM module on the Commodore computer, this is not really something usable. So we have a user, advanced user, asking for Commodore 64. This is not exactly a tool, so it actually is a good thing that we failed. So this is the first attempt, and I wanted you to show my development board. This is a Redaxy computer. You have a connector for external power source. In this case, this is just another power supply, Commodore 64 power supply. You have different states for communication. This is important for anyone who knows how Telnet works. You have some buttons related to software. And the question, why we use this external power supply? The CIA IC that is directly connected to this port in, in Commodore 64 has a maximum of 100 milliamps. And this computer is consuming up to 2.5 amps, which is an issue because of many reasons, starting from the cooling and really zero support from the manufacturer to fix this. You cannot even buy this computer without the pins, so you would need to resolder them in the other side in order to put some reasonable cooling, so it was madness. The MAX232 is used to convert the voltages during the communication. This is the piece that was used in 80s, so it meets our requirements. This is a piece of electronics that you will find in the schematics from 84, 88. So this was quite okay. This was second attempt, and as you can see, this was my first attempt of creating something on the 3D printer. Again, I wanted to show you this failure. However, the later versions were much better. It works. It has the dimension of the original parts. You can connect it. It's doing its part. The second version had no connector for the external power supply. It also used a module you can buy from China. Unfortunately, this is not really user-friendly because it doesn't have pins. So I know that we are short of time, but we have a demo. This recording was done, of course, on the one of the best DVD recorder. You use the proper technology for the proper equipment, so you will see the usual issues with the screen. So this is the terminal program that we used. Here you see the configuration. The 3 bounds were chosen. We will be describing what is happening later on, so don't worry if you will miss something. The 300 bounds was chosen just because it would be easier later on to poke around the video. Here there is a computer starting and communicating with Commodore. This is the first attempt of pulling the data from the model, from the parametric knowledge. As you can see, and you will see this later on the slides, a bunch of nonsense. Tiny Llama knows nothing about Commodore 64, okay? It is close to be Windows equivalent, whatever. Much better approach is to create a rack project. So we've put a PDF about the Commodore 64. We created a vector storage, and after asking the same question, the answer was very precise. And after this very proper answer, the chunks of data, the sources was also displayed. So yeah, this is very basic, naive rack. Naive is a type of retrieval augmented generation. You have here sources. You get the idea. Later on, we can edit the project, as you will see. I could have speeded up, sorry. But it's, as you can see from the parts of the description, the embedding model shows the parts very well. So we have everything correct, and we will have then the rack management. So yeah, That's it. Using this method, you can connect it to any other software. You can print it, whatever. So here I already told you. The question is why we didn't use 80 columns that can be software generated, for example, in Novaterm. The answer is for the quality of the output for you guys. If you are working with actual CRT equipment, then it's fine. But if you are grabbing it, well, you need to poke around a little bit, which we didn't want to do. Nice thing about this solution is that this user port with the exact pinout, voltages and everything, the communication scheme, was the same for VIC-20, for Commodore 64, for obviously the mobile version, the SX version, and Commodore 128. So we had several Commodore computers readily compatible with this module. This is how you can manage your retrieval augmented generation project. Here you have parametric knowledge, so knowledge from the small LM itself. It's worthless. Don't read it. It's really abomination. And we have the rack project that is manageable. It works. The answers are very correct. Chunks, as I described before. Yeah, so let's back to the rules. How did we make it? Well, it must be similar to authentic 80s technology. I believe that we were successful in this field. Well, maybe the next version won't be green, but it's fine. I would say that it is a pass. Should be compatible with as many Commodore models as possible. Yes, this also worked. If you will look into the Commodore history, then you will confirm it that this was the best choice. We didn't want to compromise functionality. Yes, we didn't overtake anything. We didn't force the user to use some kind of memory extension that will just shut down any other software you can write or use from 80s. So this is also fine. Easily replicable? No. Unfortunately, at this point, there is both. The problem is with power supply. There is problem with cooling of these small computers. And there is a problem with ready modules, this Max 232. If you don't have a lot of experience with electronics, you may mess things up, and you cannot find these modules with already available pins that are directed downwards. You don't have it; it is not on the market, so you cannot buy it. You need to do this. And this is it a toy, or we can actually use it? Well, I would say this is usable, so you can do stuff with it. It's fun, but it's usable, it's responsive, you can put files inside, nice. So I believe that this computer needs to be replaced with something, anything, to be honest. This is not doing the job. I hope that the Raspberry Pi Zero in future version will be similar. Then we will be able also to use a dedicated AI processor that are starting to be very popular. And with the next steps, we will do some more things around it, depending on the crowd here on this conference. So guys, thank you very much. This was our idea that we put into life, and yeah, thank you. I heard that Commodore 64 was actually very popular here in Sweden, so I hope that you like it, and we will be here with Marek to answer some of your questions you may have. So thank you again.
Yeah, you guys are heroes, seriously, once again. Insane. Insane. I love it. So, do we have any questions, surely, right? No? Yes, there will be questions. You have to, yeah, we have, no? Where? Any questions? You have to have some questions, guys. I am. This is amazing.
So
Why?
why? Why again?
Oh, but it is epic. There is,
Everything is on Commodore 64. You can
obviously.
connect to it everything. So why not, hold upon it and again prove
Again,
to the other users that
Yeah.
there is something even better.
Yeah, no, I am amazed. It's amazing. So, questions? We have a question here. Good, sir. Can we get a mic? We get a mic? Yeah, oh, we have one here.
So I'm just wondering, what about Atari then?
So, okay, that's an excellent question. Thank you. Okay, let me take that.
Is I'm offending you?
Again, please.
Is I offending you?
No. Actually, I have two factory sealed unboxed Atari 65XE in my collection. I know of these things. I've bought several of them to make sure that they are not better in any way. There are two things you need to consider if you are thinking of the Atari. So, free action. The first is you will have issues with machine learning. As I showed you before, these simple programs that you can write in BASIC and then compile, they will run faster. You will have this hard limitation on memory. Commodore 64 had 64 kilobytes, 52 available. Atari had less, 48. It was never fully utilized. If you want to have some kind of GPT-1 distilled version that came out like 2 months ago or something that is not really answering you but predicting next token, so you are asking for, I don't know, table and table standing, crossroads, building and other nonsense, then you will need to have kind of memory extension for Commodore 64. This is Rioux, Gaoram, whatever, and you need to use paging, and this has to be extremely well optimized. Again, these are not very popular modules for Atari. They are not also well supported, so you will have a lot of issues. And the third thing regarding the external modules that you can have, well, I would say that the Atari didn't convince guys like me to do such thing.
Fantastic. I changed my mind. I'm going to sell everything and buy some Commodores.
Please do that. And another question.
Yep.
Hi, hello. You stole my question from before. I was going to ask the same thing. Like, what about Atari ST, the ZX Spectrum, stuff like that? But then another question in my mind came to, do you think that this trend of LLM models will be going to other types of hardware in form of a DMake? Or do you think like this is very complex and advanced to perform?
No, it's not really so advanced. I would like to remind you that IBM 1 year ago presented like passive LLM based on discrete elements. So they are trying everything. You have dedicated TPUs in small computers, in phones. You have everyone are attempting like not Grok from Musk, but the other one manufacturing streamlining processors for LLMs. Everyone are testing new things. Remember that LLMs were not the main force behind changing nowadays computers. So we are adapting current technology to LLMs, and I would say that very soon we can see very powerful models running on dedicated equipment or old equipment. Look what Chinese done with their QN model that was and the DeepSeek that was also based on QN. they just didn't, they were not lazy, and they rewrite some of the CUDA parts of the software into the assembly of the actual CUDA hardware, and they just went skyrocketing with the performance. So it is only a matter of time when there will be much better module for this exact task, and I will come here with an update with some other functionalities, of course.
That sounds great. The reason I was wondering about that is that I think a lot of you know about the trend of does it run Doom? So then I was just like, are we getting a new variant of does it run LLM?
Well, apologies for not showing you the Doom. Yes, we have Doom for Commodore 64. A little bit better version is for Commodore VIC. But yes, there is Doom.
Thank you very much.
Thank you.
Thank you so much for a really good talk. Thank you.
Thank you. Thank you, guys.
Yes, we will just have a short break and we will start according to the schedule. So if you want to grab a coffee, a sandwich, cinnamon buns, whatever you can find, please help yourself. But we will start at, the same schedule.
To kick off day one, wasn't it? Completely mad, but I liked it. So, if you've been around this space for any time, you probably heard of Cult of the Dead Cow. And one of their members is here today to talk about a little bit of history of Cult of the Dead Cow, but most importantly, their latest privacy-focused effort, Veilid. So please join me in welcoming a legend to the stage, Christien Rioux.
Okay. Hi, everybody. The microphone works. Okay, great. Awesome. Hi, my name is Christien Rioux, otherwise known to many of you as DilDog. I should just quickly introduce myself. That's my terrible mugshot from the one time that I was conscripted to work at Microsoft briefly on a contract after having pulled their pants down on stage at DEF CON. I was not happy to be there. It was 4 weeks of total hell, but I got an opportunity to try to understand from the inside of that company the effect of the work that I was having. It turns out they were all pretty big fans of what I was doing. You can get a lot of buy-in by having people break your stuff externally. You're trying to get change made inside a large organization. Nothing does it quite like a news article that was full of unprompted security vulnerabilities. So getting things done sometimes requires some pretty drastic changes and publications. I grew up in Maine, which is the northeast United States. More cows than people in my hometown. I was pretty much the only system programmer for a 50-mile radius. Ended up really wanting to write video games, but somehow ended up in security. Turns out that the same kind of brain that you use to write 3D rendering cores is really good for writing buffer overflow exploits. And that a lot of people were not hacking Windows back in 1996, 1995. It was considered pretty lame to do because all of the cool exploits and all the really interesting data was on Unix and Windows and Linux and things like, well, Windows, it was a fallow field of new hacking, so I cut my teeth on that. Went to DEF CON 4. It was like 150 people compared to the 40,000 or whatever that they are today. Met a lot of the Cult of the Dead Cow folks in the 1996, 1997 timeframe, and joined the Loft in 1998, was responsible for Loftcrack 2.5 and a bunch of the other versions of Loftcrack that came after that. And in 1999, I hit the stage at DEF CON and released Back Orifice 2000, which was a whole lot of fun. It was a wild ride, building something that was relatively embarrassing to Microsoft, but was a much needed wake-up call for people who thought that you could market your way out of security vulnerabilities. Shortly after that, we launched a company called @Stake, which was one of the first pure-play security services providers. It wasn't a great business model, but it was one of the first sort of hacker, it was a company that advertised that we actually hired hackers. And these days, a lot of security companies will openly state that they hire hackers. Back in 1999, you didn't do that. People wouldn't trust you if you said that you hired hackers. The marketing problem was very real at that point. And I spent a bunch of time, releasing exploits and doing vulnerability research, and kind of started thinking, how do I automate that? Ended up writing one of the first resourceable, retargetable decompilation systems for arbitrary binaries, and that turned into what became Veracode in 2006. So I won't belabor myself too much here. Just want to give you a quick intro to what I've been working on. and how I got here. I worked at Apple for a little while. I released a VoIP spoofer thing, a toolkit called Stunt Banana, which is now defunct, but it was a lot of fun. And in 2020, I met a couple folks with some pretty serious ideas about, reinventing social media. And I had some ideas about building peer-to-peer networks on modern hardware. I had played with IPFS and Tor, knew a lot of those guys from back when I was at MIT. And noting that a lot of the peer-to-peer and onion routing technologies that exist were not really designed for mobile networks. I came up with this idea for this thing called Veilid. I want to talk about Veilid. So Veilid is a peer-to-peer app development framework. We have a sort of a long history in the hacktivism space with the Cult of the Dead Cow. There's 27 members up there. And over the years, we released a lot of different tools, ranging from, obviously the Back Orifice and Back Orifice 2000, which was a remote access Trojan, remote control system, a remote administration suite, let's call it that. But there's actually a whole lot of other releases that we've done over the last 30, 40 years that the group's been in existence, including things like scatter chat and some of these other tools. There's basically a history of doing things with peer-to-peer and mix-net applications. And this is sort of a next generation framework, trying to marry the concepts of onion routing and cryptographic privacy with a toolkit that provides developers access to programming idioms that make it a lot easier to develop proper mobile-friendly applications that are peer-to-peer in today's, for today's hardware. So there's a book about CDC that's coming out. Again, we had a release 2 years ago, and a new version of the book is coming out in December. If anyone wants to, pick that up and learn more about all the other folks that are in the group. And okay, so let's get into Veilid. We have the mascot of Veilid, which is a brick. His pronouns are he, them. His name is Ellet. There's a whole story behind why he's named that, but I won't get into that today. Bricks are an interesting analogy because they can be used to build things, but a properly aimed brick can change the course of history. So much like a lot of things in security, everything is dual use. So I will let Ellet introduce himself. This is Ellet.
Hi there, I'm Ellet. I'm a brick, and I'm the mascot for a cool new privacy project called Veilid. At this point, you're probably asking yourself, what is Veilid? But to answer that, we have to go all the way back in time. Back to 1984 in Lubbock, Texas, when the world's longest-running hacktivist group, Cult of the Dead Cow, was born. For 40 years, CDC has been changing the world with hacking tools, text files, and hacktivism. In fact, they even coined the phrase. Fast forward to the summer of 2023 at DEF CON, when two members of the CDC, DilDog and Metis4, released a brand new privacy project called Veilid. And now you're all caught up. But wait, no, seriously, what the heck is Veilid? Short story, Veilid is an open source peer-to-peer app framework to build privacy for all.
But what does that even mean? How does it work? What the heck is this?
Well, to explain that, we've got to break down some myths about how online communication works. So let's break this down. You have your device, your phone, you want to message your bae. So you just shoot them a text, right? They shoot a text back, that's how it works. Wrong, that's not how it works. This is what actually happens. Alright, so you have your device, you have your bae, you want to text them, but in between there's Apple, there's a cloud, there's some servers storing everything. There could be a social media overlord reading every single one of your messages, or even the government. Either way, there's always somebody in the middle listening to your conversations, storing them, possibly selling all your data. And if they're storing it, that means that hackers have the possibility of getting into it, and then who knows where it goes. And what Veilid does is take out that middleman, so it's just you and someone else chatting privately. But wait, Elliot, if there's no servers, how does that even work? So let's break this down. You little pink dot, over here we have Bay, little green dot. In between the two of you, rather than servers or some social media overlord, you have purple dots, nodes that are helping to transfer your messages. A node is just like you, except they can't read anything that you're writing because it is all encrypted, which keeps your data safe from prying eyes. And Veilid is a network made up of all of these nodes, lots of them. Each node is a different app and can be a completely different thing, but they all support each other. It doesn't matter if one app is bigger than the other, they're all equal. So every bit supports the network itself. You're a part of the network, Bay's a part of the network, we all are. So rather than the internet being, Jeff Bezos' cloud, the internet belongs to all of us, with communication between us how it's supposed to be.
Nerd alert.
And then encrypted, which is upgradable, it's written in Rust with Flutter bindings similar to Tor and IPFS, but faster, and it's completely distributed. It's a brand new way of privately communicating with your friends with no social media oligarchs, no government, and no servers storing your data, keeping it safe from prying eyes. Because Veilid is an open-sourced app development framework, anyone can build any kind of communication app on top of it, with privacy and security built in. We've built a great community of people working together to build apps that are secure and usable. All we need is you to bring your ideas and your talents to the project, so come check us out on Veilid.com and on Twitter @VeilidNetwork, at least until we build something better. I hope you learned something from this video and come join us on Veilid. Meanwhile, Elliot out.
All right. Say hi to Elliot. Thanks, Elliot. So let's just get into it. There's a lot more technical stuff about Veilid I'm going to try to cover today. You get the general idea from the video. Veilid is not just an app. It is not just a platform. It is a framework. In fact, it's not really a platform at all because we don't host anything for you. You have to think about these apps differently. Instead of uploading your app to some cloud service, you are literally just running your code, and so is everyone else. Now, the framework provides certain tools to you in a distributed algorithm. Okay, so there's certain kinds of subsystems. So you have things that let you talk directly between nodes, but there's also things that let you store and forward data and keep it in a distributed hash table across the network. So you've got a lot of different little pieces that the framework provides you, and the quest is to think differently about how you write your applications so that you can achieve a familiar and accessible feel to apps that don't feel any different to the end user, but are operating in a very different way. The Veilid framework is open source. It's Mozilla Public License 2.0. Which is one of the more permissive open source licenses for both open source and commercial uses. So we're not really judging. If you want to try to make money with your app, you're allowed to build commercial apps with it. Good luck with that. We don't have any commercial apps today, and we're not necessarily looking to assist with commercialization. However, we're trying to keep the legal side of this as simple as possible. The goal here is the framework helps you build peer-to-peer mobile-first network applications. One does have to think differently when dealing with networks that are under high churn. When you have a peer-to-peer network, you're kind of depending on all of the other nodes in the network being there for you in some way. When you're on a mobile network, you have things like switching between a cellular IP address that is a symmetric NAT and going to a Wi-Fi address, and then you drive in your car through a tunnel, and nodes come and go. The churn is a lot higher than some other peer-to-peer networks where you're used to just having cloud servers all connected to each other up 24/7. So the framework has to be written in a way that is ready for high churn. So we borrowed some of the concepts of IPFS, which is the interplanetary file system, which is a distributed block storage mechanism and a distributed hash table. And Tor, which you probably have heard of, it's the Onion router, which is a long-standing web-based TCP proxying and HTTP proxying system that provides strong anonymity guarantees when browsing the internet. So we took these ideas and we built them into this framework for applications. Now, there's a lot of talk about Web 3.0 and the future of the internet being blockchain and all this. We really wrote Veilid as a response to some of that. We think of Veilid as like Web 1.5. It's like the web we kind of wanted, the idea that everyone could serve data, and that the concept of a permanent distributed ledger of all of your transactions ad infinitum might actually be problematic to privacy someday. So we're really trying not to make transactions the core of the platform. In fact, I think you'll find that the more you look at it, the key thing is that we've designed this with sort of a right to be forgotten built in. Things that people don't care about on the network disappear from it over time, but the things that do, are higher relevance to apps will be promoted on the network and stick around. So, we have a very sort of different philosophy about how we thought about laying this out. Anyway, so the whole thing is written in Rust, has bindings for Flutter, Dart, Python, and browser JavaScript. So, it works and compiles to WebAssembly, Windows, Mac, Linux desktops, applications, iOS, and Android. So, you can write your application and have it run wherever. The idea was presented in 2020. Took us about 6 months of thinking about the social ramifications of building this before we really got started. And the network is officially working 3 years later. Took a lot of code. I've spent the lion's share of the last, some odd 4 years of my life making this, and finally starting to drum up a lot of extra support from our crew on Discord. We started a nonprofit called the Veilid Foundation, which is there to just promote the network, to help me fly to places like this and talk about it. And for our very small hosting costs, obviously with a peer-to-peer system like this, we don't really have servers. Nobody does. So the cost model is different, and that's actually another reason why we wrote this, is it changes the game for developers. If you don't have to pay a cloud bill because there is no cloud, you don't have to make the same choices that you might make in terms of things like advertisement, funding your application. So, yeah, we've had a good run. The code is getting really stable and growing a lot. And we're kind of in recruitment mode, trying to get more developers to build apps on it and to help us with the framework and documentation and all of the new set of technologies that we want to build on top of it. So yeah, we're at about 3,000 diverse members right now on the Discord. We do have documentation. There is a book that we're putting together. It's about, I'd say, about half done. These things take time, and when something is constantly moving, it's hard to document it, but we are stabilizing. We're not quite 1.0 with the framework yet. I'd say we're 0.5 right now. We do have Rust doc, so if you are interested in the shape of the API, you can go look on docs.rs. And there's various guides on how to set things up on our GitLab. So yeah, Veilid is a community first, and we have applications being written by a lot of folks that are not core team at this point. We have maybe I say a lot, it's like 5, but it's a lot compared to 0. I'll give you some examples. If you want to see one app, like right now, you could. We have this app called Intersect, written by Evelyn Hobart, and that is running a full Veilid node in your browser when you go to the site. You have to go to the insecure HTTP site, http://intersect.blog. It's not actually insecure. We do all of the work in the browser. It's just that right now, until web transport gets released for Safari, we're holding off on full HTTPS support because we don't want to have Veilid apps depend on centralized TLS and SSL certificates. It would be best if we could just have apps talking to each other without requiring a big centralized infrastructure of certificate authorities and all of that. So come on, web transport. We'll, you can do manual server certificate fingerprinting with web transport, which is really cool. Technically, we could do some of this with WebRTC as well, and we're working on that too. But anyway, Intersect is a sort of like a distributed paste bin. You can put things in various posts, hit go, save on that, and it gives you a link, and that link can be viewed by anybody that you share the link to. And it's made for small form content and things like Markdown. But it's not really stored anywhere specific. It's using our distributed hash table to store the content in an encrypted form. And there's no pastebin.com. There's no centralized place where your content lives. It just goes into Veilid and disappears until somebody decides to request it. So that's all running as a WebAssembly blob in your browser. It's actually being served off of like an S3 bucket, like a static site. So it's not like it's communicating back to some server that served the HTTP page. It's actually just running as JavaScript inside the browser. Another example app is a console mode app called StigMerge. StigMerge is sort of like BitTorrent. It sends content that you seed, so you can take a file of your choice, and it will produce a link that can be handed to people, and they can download that file from you, and then that is transferred over our private routing mechanism. I think the first thing that was shared over Veilid was the movie Chud. I've never heard of Chud. Cannibalistic humanoid underground dwellers. Anyway, after that, I think it was The Matrix. Call out to the keynote John Willender for his teardown of The Matrix yesterday. It was kind of fun. Another app that someone has done, and Brandon Vandegrift did this app called VDrop. VDrop is also sort of like is also sort of like Intersect, but for arbitrary files, and you can stream. You can send movies and sound and things into Veilid and then play them back from a link or download them. So it makes transferring files of larger size easier. And it's actually it's not like the StigMerge, which is a sort of a torrent and live transfer and seeding system. This one actually chunks the file up and sends it all over the network, and it gets stored there for the duration that people care about it. As I mentioned, things tend to fall off the network when they aren't. Nobody cares about them anymore. So this is not free unlimited storage. You can't just start putting all of your terabytes of data on Veilid. It will eventually go away if people don't also download it and care about it. So there's also a game engine that someone plugged Veilid in as the backend. You can immediately see how a peer-to-peer network like this would be useful for replacing services like Steam or Xbox Live when games just want to talk to each other and players just want to play with each other, and you want to just have a lobby where you can meet other players. A system like this is extremely useful if you don't want to have sort of some service in the middle that everyone has to pay to use. So we have a bunch of contributors. If your name could be here next if you want to help. I'd like to call out Brandon for his API maintenance, and we have a bunch of other folks. We have you can see on here also Daniel Meyerson is someone who worked on our privacy policy. I think if you have any kind of interest in legal, and the legal side of all of this, you should go check out the Veilid privacy policy. It's actually the most fun legal read you'll have in a while. It's hard to explain in legalese how you don't capture any data at all. Like if you don't do anything and you don't have anything to keep private because you don't store anything, how do you communicate that? It turns out that there's a whole lot of new things that we have to sort of navigate in that space in order to truly explain our position and get us on the same page as everybody else legally. So anyway, Veilid is important. I wouldn't do this for 4 years if I didn't feel it was an important thing to do. The cloud doesn't have to be some billionaire's computers. We have in our pockets supercomputers these days. We don't use the power that we're carrying around with us nearly as much as we could be. That should be empowering. People often view mobile devices and social media and scrolling and whatever you do on your phone as sort of a mental time suck. But it's also a huge opportunity. The problem is the model around app distribution. Developers have to monetize everything these days in order to get by. You make an app, you have to, you want it to be free, you still kind of have to stick ads in it. You're still paying a cloud bill. You still have storage and a couple $100 a month of costs at least. It can be a perverse incentive. You have to make choices that you otherwise wouldn't if you had a different model. So we're hoping to incentivize building apps a different way and changing some of the decision-making that developers have to make in order to publish their apps. So what are the risks to the actual privacy infrastructure? There are some things that we can't do anything about, but you can write apps that are accessible and you try to make things work for people so that the right things are the easiest and the hardest things that are the ones that you want people to avoid. You can think of the various kinds of risk in applications. Physical risk is like you lose your device. Someone could do a backup attack on your device, so you need to have things like encryption at rest for all of the content. I think you'll find that even popular applications that purport to be secure messengers like Signal don't necessarily encrypt everything at rest. And if you were to back up the databases from your desktop version of Signal, they're not really encrypted in a way that keeps your data private. Everything's encrypted in transit and as it flows through their servers, but once it gets to your device, it's decrypted and if someone were to capture your device, they would be able to make to dump the data very, very easily. So Veilid is designed to keep everything more secure at rest. We actually use things like the keychain on mobile devices and hardware-assisted storage, such that all of the data that is stored locally for an application is encrypted. So we're actually actively looking at these different kinds of risks and trying to make sure that the framework takes care of all of these things for you. As for adding a reporter to your war plans group chat, that is sort of an application level thing. The framework can't do a whole lot of that for you. But if I were Signal or I'm making this app called Veilid Chat, we'll talk about that in a minute. There are things you could do. For example, there are privacy-preserving ways when adding a person to a group chat to inform the chat about how many people actually know the person that you just invited. All of that could have been mitigated by simply having in the case of a peer-to-peer app, maybe a small homomorphic encryption-based submission of whether or not a particular new contact is in the contact list of all of the participants. How many people actually know this person? If you add somebody and all of a sudden it's like only one person in this chat knows that person, it should have popped up a warning. That's the kind of thing that it's too little, too late. But maybe in the future, chat apps like Veilid Chat could mitigate problems like this by being a little more proactive about reporting things like, how many people, know the person that you just added. So anyway, there's all kinds of stuff like financial risk. Veilid is a completely open source and volunteer-driven project. We don't make any money. We're a nonprofit, so we can't have our business model used against us. If we just disappeared tomorrow, the code would still be out there and you could still use it. So we're hoping to eliminate various sources of risk this way. So anyway, Veilid was designed with security in mind. It runs everywhere. It uses standard protocols. It's completely in networks, so even things like our NAT traversal and the way our nodes are connected together do not use things like centralized stun servers, so you won't see us connecting to stun.google.com or using some of the typical things that you'll find with WebRTC-based peer-to-peer systems. We've thought about strong cryptography from the beginning, and we've aimed toward building a completely resilient network. We provide device-level secret storage and an encrypted table store for all applications. So a table store is a key value store that is completely local, but is fully encrypted on disk. So this actually uses IndexedDB in the browser and SQLite natively, just because that's typically what is already available on your phone. And there's a Rust crate for that. There's also a record store, which is our distributed hash table. And this sort of mirrors how the table store works, but works across the internet. So you can allocate record keys, push data into them, and they get distributed across the network in a locality-based form. I'm going to get into that briefly just to give you an idea of why our record store is better than some of the other DHTs that are out there. And we're working on a block store for content-addressable, larger chunked data and automating the stuff that you saw with StigMerge there, that BitTorrent chunking and streaming. That's sort of like a beta of how we're working on offering that through the framework itself. Cryptography. Nothing is forever. You have good algorithms that you can choose today to use to protect your data while it's at rest and in transit, but as the inexorable march of time progresses, everything falls eventually. Cryptography is something you have to plan to have become deprecated. So over time, we expect to replace the cryptography that we're using, and we don't want users of the framework to have to worry about how that happens. So we support simultaneous crypto systems today. So if you are using our VLD 0 suite today, which is ED25519 based, tomorrow you might find that your app can use VLD1, which will be MLChem based, so for post-quantum. So having that all built into the framework frees people from having to worry too much about how the crypto does what it does, and just lets them use sort of an opinionated and well-thought-out suite of cryptographic operations uniformly. So your app doesn't have to change when our crypto does. Everything is time-stamped, everything is encrypted, everything is signed, all of the node information is signed. You'll find that spoofing a Veilid node is not only pointless, but extremely difficult. And that is a challenge. By the way, if you want to play with Veilid, hack it, tear it apart, we have probably the most unique advisory and vulnerability response platform. We actually encourage everyone to hack the crap out of Veilid. It helps us. If you find security vulnerabilities, we're probably the only project out there that will take your exploit and put it in our repository right next to the code. So that you not only get credit, you get it in the repo itself. The vulnerabilities that have been reported on Veilid are enshrined forever in an exploits folder for Veilid, because honestly, we need people to upgrade and replace the Veilid framework with a newer version when there's a vulnerability, and nothing incents people quite as much as knowing that the vulnerability's exploit is right there next to the rest of everything else. So I would say we go beyond full disclosure to actual releasing the vulnerability alongside our code. So feel free to help us in that effort. We have a schema system for everything. Everything is sort of evolution-based and upgradable over time. We have an RPC system that is upgradable over time. So as the network gets better, even older applications will be able to participate. Maybe not use some of the newer services, obviously, but the goal is that apps are not forgotten as the network improves over time. So right now we do have a crypto suite that is based on ED25519 for authentication, X25519 for key exchange, XCHA20 Poly1305 for symmetric encryption, a fast message digest called Blake 3, and a password-based hash generation, nice, slow, painful algorithm called Argon 2. And that is sort of our VLD0 suite that everyone gets to use as part of the framework. And we are a member of the Post-Quantum Computing Alliance, so we are auditioning MLChem and the other newer post-quantum authentication and encryption algorithms for inclusion and Veilid in our next release of the suite. So everything is, the takeaway here is that everything is end-to-end encrypted. All storage is encrypted at rest as well, and that your data is protected even if you lose your device. There are keys that are in the keychain that will encrypt backups going to iCloud, for example, on your mobile device. So even if someone were to break into your iCloud, download all of your Veilid app storage, they wouldn't be able to decrypt it because the key for the device was never put into the backup. So anyway, real quick about our distributed hash table. It is pretty advanced. We have this kind of crazy schema-based thing that we do. A lot of distributed hash tables are just a key and a value, an arbitrary blob of data associated with some key that it gets, tells it where in hash space to send the data. But when you try to, look at the value get and value set operations, what you're really looking at is searching the graph of the network for a particular key. It turns out that DHT really is just search, and that locality is the number one problem with search. If you distribute your data across the whole internet, it's going to be a whole lot slower to try to piece it all back together from 1 million locations than it is from one. Now, if it's properly encrypted, it really doesn't really matter that it's only being stored in sort of localized fashion, because it could be stored anywhere. And given the way that our routing works, there's a lot of opportunity to sort of scatter your data all over the network. But that doesn't mean that the data itself doesn't benefit from locality. So the way we break this down, instead of just having a key and a value, we have a key with a set of related values and a schema that lets you define how operations work on those related values. This is a more sort of advanced use, but the idea is to allow you to build operational data structures. So things like linked lists and hash tables on top of hash tables, and actually, build real programming data structures on top of the DHT. So our, things like our chat app can use the DHT to store lists of contacts or giant lists of millions of messages, with chains of validation and whatnot. And that's all supported by the framework. But that would be very, very slow if, for example, every single message was on a different IP address on the internet and you had to reach out to thousands of machines just to download your chat log. So having a DHT that understands locality and can store relevant data in places that are close to data that is relevant or cared about, is sort of the key to making this performant. It's no good if privacy gets in the way of performance, because then nobody will use it. It has to feel snappy. It has to feel quick. So the DHT gives you full control over your data. It is not based on a blockchain or coin. And the popular data that people use frequently becomes more available through our caching system. So, if you put data and nobody cares about it, you don't even open it for 2 weeks, it might be gone. But if it's frequently used, it's going to be very snappy to produce from any node. We have this notion of privacy that is backed up by an onion routing style system called Veilid private routes. Unlike Tor, we have this mechanism where both the source of a circuit, or a compiled route as we call it, and the destination both get some level of control over choosing the nodes that are in the route. We have to assume that if only one side of a communication channel were allowed to pick nodes, that one could be an attacker, and choosing nodes that only benefit them or are under their control. So we have this sort of Lego-based system where you can snap together private routes that are allocated by a destination and safety routes that are allocated by a source. So if you have a safety route, you have sender privacy. And if you have a private route, you have receiver privacy. And when you put them together, they get compiled into this compiled continuous route, where the first half of the route is possibly controlled by the sender, and the receiver can possibly control the nodes that are on the other side. And the way that works is all a bunch of math. You can kind of get into it if you want, but effectively, you can see this is the construction of how that works. And there's a secure envelope that takes your data and passes it along. We're working actively on a private routing 2.0 that makes it even harder to correlate traffic. If you were nation-state level and could follow packets around the internet, there are some giveaways about maybe how packets are flowing and whatever. It's still very challenging and beyond the scope of even well-funded organizations to understand how the data is actually flowing around Veilid. But obviously we can always be raising the bar and doing better. So feel free, if you're a crypto nerd, to pop into our Discord and criticize how we're doing private routing. We'd love to have input before we go 1.0 with a newer private routing system. But it works pretty well today. Veilid is accessible privacy. We really need things to be apps that people can use and that are designed for human beings. The reason why Tor, for example, isn't good enough for what we're trying to do is not that it isn't private. It's great privacy tool, but grandma is not going to download Tor and then proxy all over web communications. They just want apps that work the same way as every other app that they're used to. If you want to get privacy in the hands of everyone, it needs to work and feel and look like every other app. It has to work like Facebook. It has to work like Twitter. It has to work like whatever. You open up your email, the app. The login is sort of a familiar thing. The UI has got certain things people expect to work a certain way. The apps have to be accessible, and that doesn't just mean large fonts and the typical things we think about when we think of accessibility. It has to be apps that everyone can use. So it's a challenge because privacy often has a cost associated with it. We're trying to make sure that the framework takes care of the parts that are complicated, so that privacy is not just accessible to Linux nerds. I love you, Linux nerds, but it's you're not doing anybody any favors if you don't get apps in the hands of everyone and make it easy to use. So eating our own dog food here, we are building an app called Veilid Chat, which is sort of a Signal-like private messenger that uses only the Veilid network for communication. You can go check it out and get on the test flight for it right now on Apple's platform, test flight, or on the Google Play Store. We have that. Or you can just go to the code and build it yourself. It's written in Flutter. Veilid has first-class bindings for Flutter and Dart, and links in the Rust core automatically. You can see here the way this works is you basically create an account, which is a Veilid identity. and those identities could be used by multiple apps, not just Veilid Chat, but for right now, it's the only one that uses it. But there's an identity mechanism, and that you can create a user, and then you can share contacts via QR code or with a little cut and paste blob over some other medium. So you could use another chat app or email and send someone your invitation, and they can connect with you directly. And then it works just like a chat app. Today it's only text and emojis, but someday soon, hopefully, we'll have other forms of media as well. So yeah, there's all kinds of new features. I did manage to get proper font scaling and low vision support in. It's been an interesting challenge for me getting better at writing mobile apps to do this. And we're working on more public contact invitations as well. There's all kinds of challenges when you have, what if you paste an invitation to your socials, and how do you know who actually accepted your invitation? There's this whole identity thing, and we're looking very closely at how Keybase does identity proofs as an opportunity to maybe add a similar system to Veilid. Obviously, this is sort of an extension on top of the framework that we're hoping people can help us with. So anyway, all that's missing is you. Veilid is what we make of all of it. It's like it's time to overflow internet data capitalism. If you share similar ethos, feel free to hop on our Discord and help us give users the privacy that they deserve. We have a 501c3 if you want to donate. We don't ask for much, but our costs are pretty low. If you just want to help us out, that's one way to do it. We're online on Veilid.com. We have a Mastodon, we have a Twitter, we have a Discord. Until we write something better and put all of this stuff on Veilid itself, that's where you can find us. And that's it. My name's DilDog. Nice to have talked with all of you. And if you have questions, you can always reach out to me after the presentation here. Thank you.
Thank you so much. It's a fascinating idea, and I think given the state of the internet at the moment, it's an important one as well. I will be checking it out.
Thanks.
Unfortunately, we don't have time for Q&A because we need to get set up for the next speaker, but I'm sure you'll be available to answer any questions people might have.
I'll be right here.
So join me in thanking you once again, Christien.
Thank you.
And I'll see you back here in about 10 minutes.
But apparently, the second dimension has now opened, and the automotive village is now found. So you can actually find it now in the hardware and badge village thingy. It's actually there. One of the time travelers got to me and said, it's there now. So if you want to check that out, it's sponsored by Assured. You can go there and play with car things. I have no idea what it is. Yeah, so please do that. Well, firewalls, VPNs especially, someone use them. They're supposed to be secure. No? And the next speaker will sort of tell you how they might not be and how to sort of give you an idea on secure defaults or insecure defaults or misconceptions with configuration. So please help me welcome our next speaker, Alain.
All right, thank you very much. It's nice to see that a decent amount of you survived the party last night. It's good to see you here. Are we getting, yeah, okay, perfect. So maybe just to start off, do we have any SonicWall lovers in the room? Oh, we do have one, interesting. Any SonicWall haters? So mostly agnostic people. So I'll see whether I can shift your opinion on that before lunchtime by going through the presentation here. So a little bit on myself quickly. I'm currently the head of research and development at Orange Cyber Defense in Switzerland. But essentially, I've been a pen tester for over 15 years now, so working in offensive security. I do some vulnerability research, but it's not necessarily my primary focus. Though some of my colleagues often come up to me asking me, do you know a vulnerability in this solution or that solution? Most of the time I don't, but I tell them, well, I can actually have a look for it. So that's how I end up with these kind of topics. I also happen to organize our own conference, Insomniac, in Switzerland, just a little bit of promotion for us as well. But otherwise, why am I talking about this today? Well, unless you've been hibernating under a rock somewhere for the last 10 years, you've probably noticed that there rarely goes a month or two without some kind of serious vulnerability affecting one of the commercial-grade VPN vendors, be it Fortinet, Palo Alto, Checkpoint, F5, SonicWall, pretty much whichever one you can think of. They've had one or multiple vulnerabilities affect them, and not just poor vulnerabilities, they're actually security, very critical vulnerabilities in there. Most of the time, they'll be reported by Watchtower Labs because they write hilarious blog posts criticizing these solutions. Definitely recommend reading them. But that kind of got me thinking as to, it's kind of sad that these solutions which are supposed to protect us actually end up being the reason why companies get breached, because they have vulnerabilities in them. So I thought, well, why are we in this state? And why is it not really getting better? I mean, I don't think the security of VPN solutions nowadays is much better than it was 5 or 6 years ago. And I think one of the reasons behind that is probably because people have a tendency to think that they're all equally bad. So you look, I have this solution, okay, there's a vulnerability in it, I'll patch it. But all the other solutions also have vulnerabilities as well. So should I really change? Does it really change anything? So that got me started on this research project where I wanted to kind of find a way of comparing these solutions and determining whether one was better than the other. Unfortunately, I kind of got distracted a lot by actually searching for vulnerabilities rather than just comparing the metrics I wanted. But one of the more naive ways of doing this was looking at the number of CVEs affecting the different vendors. So for anybody who's actually looked at CVE information, it can be quite tricky to get what you want out of them. But wanted to give an idea of how long or what duration there is between two critical CVEs within a solution. So I highlighted here the one from SonicWall, which seems to be somewhat around 150 days between two critical CVEs. I'm not sure how accurate this data is, but it's what I got out of some research into CVEs and so on. But you can see there's quite a difference between, I don't think you'll be shocked to see Avanti up here with a little more than a month between two critical CVEs, all the way down to Checkpoint, where we're nearly at three years. So there's already a large discrepancy here between the different vendors. But I'm not sure that necessarily means that one solution is better than the other, because oftentimes people just search for vulnerabilities in more popular products, and you'll discover more vulnerabilities, or maybe you'll actually get CVEs, whereas in other cases you might not. I mean, there are lots of reasons why you might have more CVEs in one product than another. So instead of just looking at this, I kind of wanted to look at how these solutions actually protected themselves from attacks. And specifically, I was looking at memory corruption vulnerabilities. So I wanted to see how they protected against these. Kind of broke it down into 2 different categories. And I'm not showing the actual results for each vendor because I'm not completely convinced that they're perfect yet. But essentially, I broke it down into code hygiene and security features. So code hygiene would be like, what does the code look like? How dangerous does it look? How often does the application or this appliance use dangerous functions, like string copy, system, and so on? And the security features are how many mitigation features do they actually implement to protect from memory corruption, so ASLR, DEP, stack canaries, and so on. And interestingly, SonicWall did not come up very high in the list here. Specifically, in the code hygiene score, I actually had to restart or rethink how I was computing this, because I found results for all of the vendors with an initial formula, and then came up with SonicWall, which kind of destroyed everything because their results was so much poorer than all the others. So I thought, well, it's probably an interesting research project to kind of search for vulnerabilities in SonicWall, given how the code felt, essentially. So I took a bit of time, got a trial virtual machine from their website, which is practical. You can just go download them from their own website, install it on my laptop. At the time, the version was whichever version is up here, which was the latest one that was available at the time. So booted it up. What does it look like? If you want to look at the attack surface, essentially from the network, there are 2 ports which are open, port 80, 443, standard web application. And the CLI itself looks like something like here. So you don't have direct shell access. You can't execute arbitrary commands on the device, which is kind of annoying for someone who wants to do a research project, because it's very practical to be able to execute what you want, to debug things, access the file system, and so on. So the first step of my research was try to gain access to the file system, gain full access to the system itself. And I started searching for command injection vulnerabilities in the CLI, because that surprisingly works quite a lot. But I didn't find anything straight away. And instead, I used a fun technique that one of my former colleagues showed me, which is manipulating the memory of the virtual machine itself. And I wanted to try and demonstrate this live rather than show it on the slides, because I'm sure everybody likes live demos that may or may not work. So I have, that's not right. You don't see my second screen. Let's see, I'll just bring it back to the other screen then. Like this. I can do it from the same screen, I think. So I have my VM here, the virtual machine. I can just pause it, which will create a memory file of the state of the machine, like this. And then I can come and edit the memory. So to get the right one, let's put this one over here. Being an elite hacker, I do it with Notepad. So it's a somewhat large file. It's like 4 GB file. I'm just going to replace any occurrence of this string here with a shell command. So here we go. Perfect. I just want to make sure it's the same length, because otherwise VMware won't be too happy. I just replace this everywhere in the memory file. And yeah, replace 9 occurrences. Perfect. Save the file. Takes a couple seconds. And if I come back to my virtual machine over here, I can just start it again. Yeah, not a problem. Log in. And the one I targeted is the restart SSL VPN services. I click this here, click yes. And if everything went well, I now get my root shell. Nice. So that actually works surprisingly well in a lot of cases on many of the different devices I tested. So there's nothing to do specifically with SonicWall, but it is one way of getting root on a device when nothing else works, essentially. So yeah, that's just kind of showing these two slides off here. So once I had my root access, I continued analyzing the attack surface, looked at what just kind of verifying that the open ports that I had from the network, there was nothing else there. Kind of summarizing this here, we have the two web ports here and another one listening on the local interface, which happens to be a Python Flask API, which I then found through the different PS commands, just seeing what was running on there. So we essentially have an Apache server listening on the web ports, and then the Flask API, a Python Flask API, on a local host interface. And when you access it from the network, it looks like something like this. So if you've ever seen a SonicWall device, you probably have seen this web interface here. So I started off looking at how Apache was configured and came up with something like this. It's sort of a simplified overview of what's going on behind the scenes. So you have your browser here connecting to Apache, and depending on what kind of URL you're hitting, it will go through different things. There are 3 special prefixes which will end up calling a custom HTTP RP module, which I suppose is reverse proxy module, and we'll get to that a little bit later. We have some that directly call a number of Python scripts, and then you have the CGI bin folder, which just calls a number of C, C++ CGIs. And of course, all the rest are just kind of static files here. So initially, my main focus was looking at memory corruption vulnerabilities, and seeing a lot of C, C++ CGIs kind of drove me into looking further into these. And I wrote a small tool, which I just released earlier on GitHub, which kind of helps me search for the use of dangerous functions, that I'd call them, like occurrences of string copy, sprintf, things where they're not checking the bounds on the buffers and so on. So it's based on the Ghidra API. It will just kind of decompile the binary, search for any locations in there where there might be something a little bit dangerous. And it outputs something like this. Here we can see, for example, that string copy is used multiple times in different functions. So if you're lucky enough and you have debug symbols, you can actually figure out kind of what the function does and determine whether there is a chance you might be able to reach it from the web interface or not. So this is kind of how I went through all the different CGIs, looking for vulnerable calls. And I don't know if it's surprising or unsurprising, but there are a lot of these potentially vulnerable things. So obviously, using string copy or one of these functions does not mean there's a vulnerability that's there that can be exploited. But it is kind of dangerous, right? Why not check the bounds of your buffer before copying if you can? So I kind of tied all this up with another little tool which looks through all the different binaries on the system and seeing how they're interlinked, just kind of looking at the exports, the imports of different files and seeing which binary uses which library and so on, which I also just put onto GitHub a little bit earlier here. The idea was to look, well, within the user login, for example, CGI, I'm using all these different functions which come from other different libraries and so on. So it kind of just helps me map what's going on the device, pretty much. So unsurprisingly, I quite quickly found a number of memory corruption vulnerabilities here. We have one heap overflow in the Sonic file CGI. Not super interesting in the end because it requires authentication, and most of the time, it's not really what we're looking for. But just to see how trivial it is, we have a variable up here which is allocated with OX80 size. We get a argument from the URL, essentially, which is OX400 size. We do a couple string manipulations here and end up string copying it into the smaller buffer over here. So very, very trivial, obvious vulnerability. You can trigger it with a request such as this. Just have to be larger than OX80 size. Being a heap overflow, I'm not initially a binary exploitation guy, so I'm not very good at exploiting these issues. So I didn't actually find a way of getting code execution through this. And given the fact that it was post-authentication, I didn't actually spend too much time looking at it either. But I found a number of other interesting findings. One of them is that there's one specific library, libsys, which is used kind of throughout the code base, which defines a number of encoding functions, like JavaScript encode. You can imagine like HTML encoding characters to print them into a file. Now, interestingly, you have kind of the code here. It doesn't actually check for the bounds, or it doesn't check that the resulting buffer is within the size of the output buffer that you're providing it. So it's kind of expecting that the calling function will do this instead, which obviously is not really the case. And these are called throughout the code base. In unauthenticated CGIs, authenticated sheet CGIs, there are dozens, if not hundreds of occasions where you have overflows because of this. Now, I reported some of them, and I'll talk about that a little bit later, but I'm convinced that there are a lot more issues that I didn't necessarily investigate too much here. So one of the interesting occurrences I found was in an unauthenticated CGI called CIFS Navigate, which, why it's accessible without authentication, I don't know. It kind of gives you a sort of graphical interface to navigate a share. So no authentication required, very similar to pre-4. We get a parameter from the URL, OX400 size. We do some string manipulations in here to kind of figure out what the share is, what the server is, and so on. And eventually, we use the double escape special, I like the naming of it, function on the input, and we store it into a destination buffer, which is actually smaller than the original input buffer. So even if you're multiplying by 5 the size of the buffer here when you're encoding it, it's not actually necessary to overflow the buffer. So again, a very trivial vulnerability. This time it's a stack-based overflow, and accessible without authentication, which is always cool. So was I able to directly exploit this? Well, there are a number of exploit mitigations on the system. So I don't know how familiar you all are with binary exploitation and mitigations, but there can be a lot of protections to prevent the exploitation of buffer overflows. Some of the more common ones we have here, so address-space layout randomization, which is the idea of having your different libraries mapped at random places in memory, so you don't know where they are. Data execution prevention, which prevents executing the stack, for example. The one I want to mention here are the stack canaries, which is the one that kind of annoyed me here. The idea is that whenever you're calling a function, you're going to be putting the return address onto the stack, and then you add a random or an arbitrary canary on there so that if somebody actually overflows a buffer, they cannot take control of the return address and the instruction pointer without destroying the canary. So that's the idea. And that's unfortunately for me, or fortunately for SonicWall, what they had in place on most of their CGIs. So you can run a tool such as checksec, which will look at which security features are implemented on which files and so on. So it just kind of gives you a little sneak peek at that here. The fact no canary is found does not necessarily mean that the canary is specifically lacking. It's just that compilers don't always add the canary if there's no reason to. So in most cases, canaries are actually there, and there's no trivial way of getting around this. So technically, there are potential ways of getting around this, especially because of the fact that in this case, it's a 32-bit Linux system. And in that case, a canary is actually only 24 bits of entropy. It uses 3 bytes followed by a null byte. The null byte is there because it is the terminating string character, so that if you have an overflow with a null byte, it will essentially stop at the null byte. And unfortunately, within the code base that I was searching for, pretty much all the vulnerabilities I discovered, all the stack-based overflows I discovered, used string functions, so string copy, sprintf, strn copy, and so on, which made it impossible to actually overwrite the stack canary. So I could have potentially brute forced it, but I couldn't actually write the value I wanted in there. Potentially, what could be possible is if you have multiple successive overflows, or consecutive overflows, you could actually overwrite the canary and then with a second one, insert a null byte into the correct location. It might look like something like this, where we have multiple calls to the vulnerable function, So technically, this is probably exploitable, but I didn't actually go in too deep into this one because it requires admin access already, and I never actually figured out how to get to this part of the code in the appliance itself. So pretty sure there are other places where it might be exploitable, but I didn't actually find them directly. So I kind of abandoned the idea of looking for these overflows for a little while and expanded the research surface to look at other things, the Apache configuration, authentication, which was done to the different CGIs, to the Python APIs and so on. So one of the interesting things that I discovered here, and probably the most important finding I had in the end, was that the Apache configuration on SonicWall was vulnerable to the path confusion vulnerability that was presented by Orange Tsai at Black Hat last year. So I don't know how many of you are familiar with that. But essentially, Apache modules will all consecutively parse the HTTP request that's coming in, and they don't all parse it in the same manner. Shocker. Which leads to some inconsistencies, and in certain cases, they can be exploited to do various things. One of them, which is especially fun, is when you have a rewrite rule, such as the one that we have here. So if you're rewriting everything that's in /html/something to /something.html, there's an interesting quirk in Apache, which was if you actually access this page, you'd think that it should go search for the file down here, but actually it would look in both locations, either within the doc root or at the root of your actual server, which is pretty crazy when you think about it, because it allows you to read somewhat arbitrary files outside of the doc root. Now, there's one requirement, or two requirements, I guess. One of them is that you need a rewrite rule such as this. The other one is that you have to actually have like a directory set up in the Apache configuration somewhere, which does not deny access. So it doesn't have to explicitly allow access, but it doesn't have to deny it. Now, thankfully, in SonicWall, we have a nice directive which is up here, which takes the root of the appliance and does not deny access. So great. So that requirement is fulfilled. And the second one is this nifty little CSS rule. You actually have the comment saying exactly what it does. But essentially, it strips off the version number from the CSS file that you're loading. So I'll try and demonstrate this again here. See if, oh wait, no. Like this. Sorry. So here we go. Perfect. So this is kind of the original request. You'd have a request done to fileshare.version.css. And what happens is you can actually trick this by writing the .css here and then adding a %3s, which is a question mark, add a dot, and it will still load the same file. Will it? Yeah, perfect. I'm still loading the CSS file. And this kind of proves that the vulnerability is present. Obviously, when this worked, I was like, oh, great. Let's try and read etc password, for example, because that's what everybody does. And that doesn't work. It actually has nothing to do with the vulnerability itself. It's a different protection in Apache, in this case, or in the configuration they have, which kind of blocks access to anything that starts with etc. But that doesn't really matter too much, because there are a lot of other things, interesting files on the appliance, which are not in etc. One of them being a SQLite database, which is in /tmp/temp.db, which contains all the authenticated sessions. I'm not sure if I can necessarily find them in here. But somewhere in here, you have the base64 encoded session information of anybody who's connected. And this is obviously accessible without authentication. You can access this URL and immediately then circumvent authentication, compromise anybody's account who is connected to the device. So that was pretty sweet. Maybe even more interestingly for me when I was searching for this was that you can also recover the Apache logs, the same kind of URL here. And And within the logs, oh yeah, we don't actually see them here. Within the logs, I'll show them afterwards. Apache will have a detailed stack trace of any memory corruption, essentially. I'll have it on the slides. There we go. Slides again. So this is an example of the file share. The etc password doesn't work. The SQLite database, which you can then just kind of, once you've downloaded it, you can access it like any other SQLite database, recover the sessions from here. But the other interesting file was the HTTP DilDog, which stored stack traces of anything that went wrong. So when you crashed the program, you'd have a dump, essentially, of the memory here, which, importantly for me, had the memory addresses of all the different modules in there. So if you've done any binary exploitation, having a memory leak or an information leak is pretty much required to be able to bypass ASLR or PIE. And in this case, this was great because it gives me pretty much all the information I need. So we'll keep that in mind for now and come back to the memory corruption later. But I kept on analyzing the authentication also to the application, to the web app, and noticed that there are various ways they can implement multi-factor authentication, be it through one-time password, certificate-based authentication. There may be some others as well. I don't actually know SonicWall all that well. But it seems like implementing multi-factor authentication is quite difficult. So I find a few different issues in here. One of them is linked to the one-time passwords. So if you happen to have set up your account with one-time passwords, so a token which you use to log in, you can also generate backup codes, which is quite common. Like pretty much all applications will support generating backup codes. And they can be generated with a request such as this. So you access CGI-bin backup code, action generate, and it will give you the different codes here. So I looked at the code behind this, and it looks something like this. So can anybody spot what the issue is here? So they're essentially doing the one thing that you should never do when generating random numbers is they seed the random number generator with the current time. So the time in seconds, the epoch time here. So essentially, if you know at what time someone generated backup codes, you can know exactly which codes were generated. So it's a terrible way of doing things. Even more so because of the fact that the request to generate the codes does not have any cross-site request forgery protection against there. So you can actually force a user to generate backup codes at a specific time if you get the user to visit your own website or something like that, and then you'll know what the backup codes of that user is. So that was a fun little finding. Another interesting one is in the certificate-based authentication mechanism, which works something like this, or at least that's my understanding of how it works, where your browser will send the certificate information to Apache. Apache will check that you're actually allowed to connect, verify the certificate and everything, and then it will send off that information to the Flask API, the Python API, with this information in environment variables. That's relatively standard when you have a reverse proxy working in there. And then Flask would retrieve these parameters with this code here. Now, you'll notice they're using a module called request parser. And in request parser, there is one option that you can add to this, which is specifying the location of the parameter, saying essentially where you want the source of the parameter to be. So you notice some of the ones here specify that it has to be from the environment. But in this case, it doesn't specify that. And what that means is that you can actually just send these parameters in the post request when you're logging in to tell them, well, actually, SSL client verify is success. It's encoded in base 64, but that's what we have here. And you can encode your own subject DN and your issuer DN in here as well. So you can completely bypass the certificate-based authentication by essentially telling the Flask API that you are authenticated correctly, which I thought was pretty cool. So going a little bit further, this reverse proxy module I thought was very interesting because it essentially allows users to access websites through the SonicWall device. So it really functions as a sort of reverse proxy. The URLs will look like this, /go/ pretty much whatever you want here. And at least in the default setup, there's no kind of firewalling, so you can access things that are behind the device or on the internet or wherever you want. I expect that in more productive environments, you probably wouldn't have that. But as it stood in my test environment, I could pretty much reach whatever I wanted through here after authentication. And this reverse proxy module also supports single sign-on. So if the backend server you're trying to reach requests authentication, it will automatically try to authenticate with your credentials. So relatively standard reverse proxy features there. And so I kind of dug into this, used the same tooling I had with for the CGIs, looking for potential dangerous function calls. One that caught my attention was this specific function here, which is related to how the server deals with responses from backend servers that request digest authentication or NTLM authentication, because there were references to str and cat. Now, it turned out that there was nothing to do with str and cat here, but in this specific function, the reverse proxy module will get the authorization header from the server, strip the NTLM part, and then decode in base 64 that value into a static buffer, which is the one which is here, so 1076 bytes. And unfortunately, the base 64 decoding will not check the size of the output buffer. You're supposed to call another one, which is APR base 64 decode length here before doing so. But what this allows us to do is not only overflow the buffer, but since it's actually decoding in base 64, we can actually start writing null bytes now into the right places to bypass the canary protection. So now we have pretty much everything we need. We can, as I mentioned, the stack canaries can now somewhat be bypassed because you can write the null byte by base 64 decoding. There are only the 24 bits of entropy, which means that there can only be like 16 million different canary values, which may seem like a lot, but if you suppose you can do 100 or 200 requests per second to a device, you'll be able to find it within a couple days, I think, something like that. I did some math yesterday trying to figure that out, but I think it's something like that. So for the other protections, address space layout randomization, or PIE, we can kind of bypass that with the fact that we're able to retrieve the HTTP log file and see all the base addresses in there, or all the memory addresses, which is cool. The only thing you need is to be able to crash the device once to get the stack trace in the logs, which is incredibly easy. There's another way of doing it here with this cookie, just yet another overflow memory corruption somewhere, which you can then recover in the log file. So kind of putting all of this together, I wrote a very simple kind of ROP chain based out of all kinds of gadgets that I found in libc. And this ROP chain just simply calls a system command with a reverse bash shell that we have here. So essentially, to be able to exploit this one altogether, you start off by leaking a valid session identifier from the temporary SQLite database. You generate a stack trace with any one of the overflows that I've already mentioned before. You get the libc base address from the log file. You create your ROP chain. You then spawn a fake web server, which will send your payload back to the appliance when you force the appliance to connect to it. So I've also put up a POC code up on GitHub. So I'm definitely not a particularly good developer or code writer, so don't look at the code too much. But I'll kind of show it in use here. So, yep. So I still have my SonicWall running. Can I actually reach it? Perfect. So here we go. So I'm going to exploit this specific IP on this specific port. I'm going to ask it to connect back to my fake web server on this port here, and then that will trigger a reverse shell onto my machine on this port here. And we will see if this works. Looking good. Perfect. Hey! Thank you. So in this case, we're not actually running as root. We're running as the nobody user, as the Apache user. But I'll let whoever wants to try find privilege escalation vulnerabilities in there. It shouldn't be too difficult. All right. So at the time, I did a quick look on Shodan to see how many potential boxes you could pop. There are about 10,000 of them online, mostly in the States. But there are a number of those that could have been exploited. I don't know exactly how many, because depending on the version, maybe older versions were not as exploitable, I don't know. But nevertheless, it doesn't give me much assurance as to how secure this device is. So for the timeline itself, so I found those in October last year, more or less. Reported them at that point. It took SonicWall, they actually responded quite quickly. Within a couple of weeks, they told me that the issues had been fixed. I checked that everything had actually been fixed. And then it took them another month, nearly, to actually release a patch. And I got a number of CVEs here. They kind of bunched all the heap overflows into one CVE and all the stack-based overflows into another, apart from the reverse proxy one, which was separate. But yeah, so I got a number of CVEs. I got a thank you message, and that's pretty much it. So if you're searching for bounties, I would not necessarily target SonicWall unless you're going to sell them on somebody else, which I would not recommend, obviously. But yeah, to kind of wrap things up, it took them about, as I mentioned, 6 weeks to respond, which is a lot better than the last time I reported a vulnerability to them. It was about 5 or 6 years ago. It took them 6 months. So there's some improvement. But I think it's still kind of sad that we have security devices that are so vulnerable. I mean, we're in 2025 and we still have commercial-grade VPN appliances that have string copy used throughout their code base, which I don't think is normal. But I do somewhat understand the reasons behind that, because I think the incentives for vendors, and I mentioned security vendors, but all vendors pretty much, are not necessarily aligned with security. I mean, vendors want to provide cheap products so that people will buy them, with lots of features and very fast. But unfortunately, that usually means that you're probably not going to have the best developers, you're going to have a larger attack surface, and you might disable security features so that things go faster. And that's what people look at when they're buying a product. You want something that's cheap, fast, and has all the features you want. So unfortunately, security is kind of an afterthought in many cases. So can we actually do better? I certainly hope so. I think one of the ways of doing this is kind of incentivizing vendors to promote the security of their products, if you will. What's been done up to now, it's kind of also what I've been doing during this presentation, is kind of shaming the vendors for doing terrible security. I don't think that works so well, because as I mentioned, I'm not sure we're much better off nowadays than 5 years ago, because of the fact that people just assume that other vendors are just as bad or just as good. So I think we have to find a way to actually compare these different solutions, which was kind of the idea of my initial research project, which is, I'll get to it at some point, finding metrics that you can actually compare between the different vendors and show that one is better than the other. I think there have been some developments on the legal side as well, where I think it could be an idea where you try and fine companies for selling you terrible products. And there's something that was changed in the Product Liability Directive, some kind of European law. I'm not a lawyer at all, so I'm not entirely sure about this. But like, digital software is now included in that. So if you have software that actually harms people, you could potentially be liable. So there are all kinds of ideas that could hopefully kind of push these vendors into doing a little bit better. So that's pretty much all I have for you. Thank you for listening. I put up the different code on GitHub. You have a blog post as well, kind of detailing everything I talked about here. But otherwise, I'm happy to answer any questions.
So, do we have any questions from the audience? Don't leave, guys. We have very important stuff going on after the talk, so don't leave. Stay put. Any questions? Come on, you can do it. Don't you dare have a question? Then I'll have a question. So, looking at really good talk and really good research, I share your I have the same idea. I have a really broken past with Juniper back in the day. So, do you think it's also it's really expensive to develop products? That's what you yeah. and the gist of actually upgrading them is slow.
Yes, and we've kind of pushed the upgrade philosophy, like you're pushing your customers to upgrade constantly, so they have to buy licenses to get the upgrades. So you've kind of decided, well, they're going to pay for the security, right? They're going to pay for the updates and so on. So you're offloading completely the security to your customers, which is interesting that we've kind of accepted that.
Yeah, right? Really weird. So who's next on the list?
Good question.
Yeah.
So you have time to dig into other ones.
Yeah. No, really interesting. Thanks for sharing it with us.
Thank you.
Okay, don't leave, everybody. So now we're going to do some adulting and a bunch of fun stuff. And there is a prize for everyone in here. So stay put. If there is a friend who's not here, use your instant messaging app to get them in the room now. Or else I'll bring the bell, and everyone knows how subtle and discreet that is. So get in here, right?
Yeah.
Happy you're here. I missed you. I was scared I had to do it alone.
Oh, no worries. I'm always here for you.
Talk a little bit.
Okay, I'll talk a little bit. What should we talk about? So have you had a good time today so far? I think we've had some amazing talks. This one was great. I really liked the Veilid talk as well. We actually had to ask people to let him get off the stage before we started asking him questions. So I think that was a really, really good sign. And how about
Doing well.
the?
Doing really
Yeah,
well.
I'm really,
Yeah.
you know, I'm vamping here.
Yeah. Continue vamping, please.
The Commodore 64 guys, that was crazy.
Insane.
Absolutely
Yeah,
nuts.
how cool is that, though?
He owns 120 Commodore 64s.
Yeah.
Some of them actually work as well. How are we going?
I think we're going pretty good.
Should I put you on?
I am
All right,
some
we're almost
kind of
there,
a master.
guys.
Click.
Sorry, I know you're hungry.
Shitulu, that's cool. No,
yeah.
wrong screen, wrong screen, wrong screen.
This is professional stuff, guys.
Yeah. The year the desktop is now.
Open your history. Let's see.
No, don't. I was like, is there? Fuck.
What are you?
I have no idea. It's just, it's not me anymore, man.
You're here.
It's a shell of me.
Press the button.
Press the button.
Oh yeah, the one that says slideshow. Give him a hand. Okay.
So we're gonna eat today,
Yeah, we are.
hopefully.
And you know how this works by now, but if some of you guys weren't here yesterday,
Yeah. Ask Benjamin.
yeah, exactly.
No,
you
but
got-
lanyard is key still. Find the corresponding vulnerability in color. If you're colorblind, find the vulnerability.
Yeah, there's a tiny logo somewhere. It's a great system.
Yeah,
And then follow the signs that matches that color or vulnerability.
exactly. And it will not be 12. It will be, yeah, it will be 12 now.
It will be 12,
Yeah.
hopefully.
Sorry for the mix-up yesterday, but that's the
And
case.
if it's not 12 this time, then I don't know.
Exactly.
break
And
it.
now we will have an award ceremony.
Right, so we had some competitions this year.
Hold on.
For what?
Because I have prepared something.
Okay, then
Yeah.
go ahead. I thought I was still back.
But everyone gets an award, because guess what showed up? The T-shirts.
Yes. And at the end of this, we will tell you where to find them.
That is so much better than I had planned.
See, you know, this is why we're professional.
Thank you so much. Moving on. This is the timer, by the way. It's here, which we don't need anymore. So, the CTF has been concluded.
Wow.
You can't see anything about this, because this is just a slide for me to sort of catch your attention and be focused.
There's a lot of pretty colors.
Yeah. So, I would say that I wasn't surprised when this team told me that they were going to compete,
Right.
because they are old school friends. And they won with some kind of a landslide. They almost have the double amount of points as number 2. So,
Who could it be?
who could it be?
And more importantly, what will they win?
Exactly. Should we tell everyone now or should we wait? We rehearsed this, by the way.
Yeah.
Did it.
No, I think.
So, without further ado,
the
Hack Street Boys,
Are you around?
get up on
Hack Street
stage.
Boys? Good job.
Was it hard? Kinda? So did Chalmers do a good job? You can hold the mic.
Yeah,
yeah.
Great job.
Great job.
From Chalmers and the sponsors and all the other crew.
Cool.
Yeah.
Talkative crowd.
Yeah, it was great. I'm
Wow.
probably hungover.
We have prizes, though.
Yeah, we do.
Yeah.
And as usual, I didn't get a chance to play the CDF this year either. Maybe
No,
next
me
time.
neither. So
But
if
yeah, we
every
have
one
some.
of you just undress and I'll bring forth the tattoo artist, it's going to be a small thing. No one will notice. Covers half the face. It's going to be nice. No, it's actually not that. So I think we should just bring everything up since the badge CTF sort of failed. Now we get a last-minute edition of prizes, which is also not rehearsed. But here's you one with the actual prizes. So this year we tried to take a different... Oh, shit, Joel is here. Also from Hack Street Boys. Late, but he's here.
Should I just pour these out on the floor?
Sorry?
Should I just pour these out on the floor?
Yeah, let's do that. Let's
Okay,
do that.
that's fun.
So instead, to sort of bring back the culture thingy, we bought board games for all the money that we have. And we have some electronics kits as well. Just bring them forth
I'll
as
bring
well.
those as well.
Come on. Because that's cool. That's cool. We don't want to...
Yeah, we want you guys to go more analog with the gaming.
Yeah, exactly.
And then you can also build...
Can't really see the games. We have to do this
Yeah, this
and
is really thought out and well planned.
It is. You can see it's an organized pile. That's what I love. It's like my home. Not really. So, guys, pick anything you want and then leave the stage.
Yeah, and we'll watch you do it. So, I mean, pick correctly. What do you want?
A better one.
So he's going for the robot kit, and what do we have? Pandemic?
Pandemic. That's a good game, though.
Oh, another Arduino.
Yeah, Arduino guy, starter kit. Clever
Hitster.
boy.
All right, getting ready
Hitster.
for karaoke next
Yeah,
year.
yeah, you have to sing next year you have to sing, Linus. Yeah.
All right. So I guess we'll keep the rest of these prices for next year.
Yeah, I guess so. If you take another
All
one.
right, you can take another one.
Take another one.
Go on.
It's Security Fest once a year.
Yeah.
Best card game in the world, Shanti. It's addictive.
Yeah, it only
we need
takes
to play
about 8
next year.
hours to
I
set
will
up.
win. I will win.
All right. Thank you guys so much
Thank
again
you
for
so
playing
much.
and winning. And
a late edition, I guess.
here.
So here from Assured, who has a prize as well. You want to do it, Emily?
Yeah.
Yes, here's Emily.
Yes.
We had this satellite challenge this year. It has some challenges. Satellite broke this morning, but
did it crash?
yesterday it was one person who took 4 flags, and that was the most flags someone did. And Assured has sponsored a special prize for this. So I would like Illuminati Marken up on stage.
Stay around.
Are you here? Yay! What is it?
You want to say something?
Tell us.
Shit, this is loud. All right.
This is where we're at.
Yeah,
You like
all
it,
right,
bro?
all right. I love it. Thank you for the challenge. It was amazing. It was fun, challenging, and yeah.
Thank your parents.
My parents, my mother. Yeah.
Hi, Mom.
Okay.
Hi, Mom. I'm on
Hi,
internet.
Mom. Hi, Mom. I'm not used to this.
No,
I'm not like you, Jesper.
Me neither.
I don't.
What
get
did you
up-
win, though?
I don't
Everyone
know.
is curious. What did you
I
win?
don't.
Oh, it's an Hack or F.
Yeah, I got 2 of those.
Wow.
Just kidding. Just kidding.
Wow.
I got a Blade RF. Now I have a Hack RF as well. Thank you.
Thanks, and thank you, Assured.
Thank you, Assured. And we have a tinkerer among us.
Do we?
Great work. Yeah.
I think we have a lot of those.
Everyone asked me yesterday, who is this guy, Luve? And I was like, what do you mean? I would describe him to
Oh,
me.
right, yeah.
And I was like, yeah, well, I don't know. I can point him out. And I never found him. I was like, who is Luve? And it's like, everyone's asking who Luve is. What's going on? But he actually inserted himself into the CTF, so that sort of explains it. So now I know why. And here is Luve for everyone who wondered who he was and didn't find him. And he's going to
One of the
present
best
another
organizers.
little challenge prize.
So this year we had some villages. One of them was called Sugsta, which was robot racing with with vacuum cleaners. And some people managed to go all the way around this track, which was kind of insane because
it looked completely impossible.
Impossible. It was Xiaomi's official app.
Oh, so that explains it.
So we have two people who actually topped the leaderboard. It's Seapalm and Klondike.
Get on stage. No. Okay.
Okay, then we need to get Ove on stage.
All right.
Yep.
Do we have these people?
More.
Well, that kind of fizzled out, but you know what? If you're in the audience, come find Louv afterwards.
Yeah.
Come find me and get your vacuum cleaner.
Yeah. More broken now than ever.
Yeah. And we have one additional one. This is not, we're not done. We have one from Splunk as well, the racing stuff.
Yeah.
I can't see if we have anyone from Splunk here. Should be. There she is.
Yeah. Here we go.
Yeah, so who did try the race sim? Why is one? Good.
We got one.
It's
Well,
like
that's an easy
people
way to
just,
win.
second day of Security Fest, people just get mute. It's just like, who won?
Let us eat.
Exactly. No, you're not getting there yet. So, here to present the award for Best Racing Driver at Security Fest 2005.
2005.
25, sorry. Go ahead.
I would just like to start by thanking what an awesome event it has been. It's like been the best Security Fest I've ever been to.
Was it the first?
Thank you.
Thank you very much.
So now for the top 3 who attended to the rig. I hope they're not standing in line for the T-shirts, though, because then they're going to miss out.
No.
And I will go for the next one. So on 3rd place, we have Thomas. There's
Thomas?
probably a lot of Thomases.
Anyone named Thomas?
The Thomas who actually rode the race simulator.
And I do recognize his face, so don't try me.
Thomas?
No?
Get over here.
Well,
No
Or
prizes
maybe?
for you. They was like, I'm getting out of this. Bye-bye, guys.
Okay, I'll go with the runner-up here.
Yep.
And then we'll see what we do. Simon, 2nd place. Simon with a 1 and a 1, of
Are
course.
these guys in the bar already?
Yeah, it is open. Simon? No, Simon?
Oh, okay.
Anyone wants to be Simon? No?
I don't recognize that Simon, so it could be anyone.
Yeah, right?
Yeah.
Hacking is always a thing.
3rd time's the charm?
Yeah.
Let's go for the winner then.
Yeah.
Hope he's here. Tom Fisk, where are you?
Tom Fisk.
Now, are you really Tom Fisk?
I can actually remember him because I was like, did you say Tom Fisk? Yeah, I did. Tom Fisk.
All right.
Yeah.
Makes sense.
Congratulations.
Okay, we're not going to wait for the others, so I'm just going to go down the list.
Perfect.
And you can hope that you're one of the ones who actually attended. Doesn't mean
And
that
are in the
we're
room,
best.
which would be good, I guess.
Max.
Max?
No, Max?
Max.
Oh, yeah, we got one.
We have him!
Oh!
Yay!
Sebbe 3.
Sebbe 3.
Yeah. Sorry, guys. Amazing.
Perfect.
Thank you.
And thank you, Splunk.
Thank you, Splunk. Show them some love. Okay, so now we are going to go and eat, but we are going to fetch some T-shirts as well.
Yes.
So charge! No, just kidding.
Yeah, so in an orderly fashion, and sorry for the delay, at least they got here before the end of the second day this year.
But it's more of a theme, right? They need to be late. We need to give you something to look forward to when it's dark outside.
So T-shirts are being handed out in the little room called Stockholm. It's to the left of the entrance where you came in.
Where you found the sticker
Go
swap
there,
thing?
it's first come, first serve, get your size, and then go to lunch, and we'll be back here at 1:30.
Exactly.
Thank you.
How fast they are. Look, they're roaming. They're roaming, man. Again, so nice. It's really nice for us as organizers to see that the second day and we're moving after lunch, and there's still a lot of people here not spazzing out, laying around in piles, which is really good. Really, really good. I'm really happy about that. So let's give ourselves an applause. I'll applaud you guys. Thank you so much for this. Really good. So we're switching it up a little bit, so don't leave after this talk, because the next talk will start 5 minutes after. So it's just like, pop, pop. So before I introduce the next speaker, there will not be a Q&A for this session, because we need to get things going, right? So find him afterwards. So now it's time for us that does shenanigans for a living to learn from the man who tries to actually find what we did. And he's going to tell us how we're doing everything wrong. So please help me welcome Stephan.
Oh, well. Okay, I pushed the button, my fingers on a button. Hi, everybody. Thanks for attending this talk, and thanks for this nice intro. It's my second talk, or my second time here at Security Fest, and it really feels like homecoming, thanks to Jesper and the whole crew. So I'm talking about anti-forensics, a little bit about me. I'm doing incident response for a living, otherwise I couldn't do that talk, apparently. So you will find me on all platforms, because we don't have much time for a Q&A. Just text me. I'm really responsive. I try to answer all your questions. Just give me a ping. I'm also on social media. I blog too. I'm Swiss. I love mountains. I love hiking. Typical cliche. Check. So let's get covered. And also, please pay attention to the upper left corner, because I divided the slides to red, blue, and some kind of purplish, because I tried to focus about the forensics, anti-forensics techniques, how we detect these techniques, and then later on how we can improve it. So yeah, let's get going. So mandatory introduction. This paper here, How to Cover Your Tracks, was created or was published 1995. I'm that old that I remember reading that paper back in 97, 98, and I was a little boy, like 12, 13 years old, and I was, what the heck I'm reading here? I had zero clue. But back reading that paper now, 30 years later, some of these techniques of how to cover your tracks in Linux systems are still popular from the attackers. Just picture that one. Clearing log files on Linux, yeah, you're nodding your head because it's silly. And also, I will speaking about Linux rootkits later on in the year on another conference. And some of these techniques used by rootkits around 2000, 2005 are also used by APTs. Isn't that crazy? Because we as defenders, we as blue teaming, we always lagging a bit behind. And sometimes that's really nagging on me sometimes, because I think why we cannot be better as a community, as defenders. I know you're also shaking your head. I'm shaking my head all the time. So yeah, let's get going. Sometimes the problem I see is, and also Florian Roth, the famous German security researcher, always if you're following him along on Twitter, you know he loves to start fights with the red sites about, hey, another one published a red teaming tool, you're helping effectively with the attackers to bypass our defenses, to breach the perimeter. And the same for here. We see public available tools which might help you to cover your tracks on systems. That one here is called Forensia. It's an open source tool you find on GitHub. Popularly, it has a lot of stars there. Keep in mind that these techniques here are a subset of techniques you could use. They try to cover or delete most of the tracks we as incident responders use, but it's not enough, as we will later see in the slides. And I love that quote here can be used to test the capabilities of your incident response forensic team. I would say challenge accepted. This one here is from Rob Lee, one of the really, really famous guys in our industry. He used to be, or he is still a SANS instructor. This talk here, Pentest Hackfest, he's talking about anti-forensics. And he asking the question, how good is anti-forensics? And then he mentioned a couple of things like deleting registry keys, timestamping, file deletion, all the things. Most of these things I'm trying to cover here in that talk. How good is it? How we can reverse some of these anti-forensic techniques, and yeah, if it's still used in the past or still used by APTs nowadays. First topic is cover your tracks. Maybe you know, maybe you don't know, when you are deleting a file in Windows, that file is not automatically just deleted. Windows use something called the NTFS table. NTFS, you can picture it kind of like a phone book. Every file on Windows, every directory on Windows have an ID. It's called the master file table ID. So when I go in Explorer and I'm just deleting a file, that file is not deleted. Even if you delete a file from the recycle bin, that file is not deleted on the file system. That file is marked as free, as to be deleted by Windows. So what can I do as an incident responder? I find traces of an application. So we see here rclone.conf. What is rclone? Rclone is a tool used by, or loved by, attackers to exfiltrate data out of our networks. This software uses a configuration file, despite rclone.conf, right? When I see traces from different artifacts on the system, web browsing, shim cache, etc., on the file system, I can search for this file here. What I'm doing, so please stay in the room afterwards, because two really legends will talk about Velociraptor. The screenshot on the right side here is Velociraptor. These two legends after my talk, Eric and his fiance, I don't know, I'm not sure, we'll talk about Velociraptor in depth. So Velociraptor is an open source incident response tool we can use to query the NTFS, the master file table for information for files. What I'm doing here, I'm searching the master file table for information about a file called rclone.conf. Simple, right? It's just a GUI. Everybody can do that. Surprisingly, I get a hit back. This is from a real incident. The attacker deleted the rclone.conf file, but I still find traces in the master file table. So you see 4 hits inside the master file table. The file was not present on the disk. I mean, on the disk with Windows Explorer or so, I cannot see it. But with forensic skills and forensic tools, I can find that file. Here on the left side of the slide, you see the master file table ID. That's a unique ID every file has in Windows. Again, to recap here, even if I delete the file, it's still on disk, it's still in that directory. With the information of the MFT ID, I can use another Velociraptor artifact. It's called NTFS recover. And surprisingly, I find the plain text information of a deleted file. So the attacker, they deleted the file after exfiltration the data out of the network. They tried to cover their tracks while deleting files, but still I find the information on the file system. Why is that important? Because with that information, that's the clear text password to the attacker's server. So what we did, we passed on that information to law enforcement logged into that server, law enforcement was able to delete the stolen data from the customer. So one extortion method gone. Maybe the network is still encrypted, but they cannot do the double extortion. Or law enforcement still have further investigation points, so they can ask Mega or another online provider, hey, who rented that account? Who is responsible for the data exfiltration? Because attackers know that we have the capabilities of recovering data, they use sometimes a thing called, or a tool called SDelete. Keep in mind, SDelete is super known. Everybody knows about the forensic traces. SDelete leaves behind the MFT and the journal. It's flagged by multiple antivirus tools as well. Inversosec, so she wrote about it, Hack the Box wrote about it, and sometimes I think all the people in our community are just recycling stuff. You want to talk about anti-forensics? Yeah, why not talk about SDelete? Everybody knows about SDelete, that is not novel content. So I thought, what is the exact purpose of SDelete? What SDelete is doing in a nutshell is it just overwrites the content of the file several times. It renames the file several times to cover the tracks. So that technique here will not be possible again. Funny thing is, again, you leave traces when you are using SDelete. So that's why this slide here is marked purple. We want to do better as attackers. So now I'm a red hat hacker. Turns out, with just a little PowerShell knowledge, I can recreate that SDelete functionality. What I'm doing here is I just manually rename the file multiple times and just pump in random content into the file. Easy done. Not flagged by antivirus, not flagged by other mechanisms. Keep in mind, this will leave traces as well, as we will later see on the slides. So, more deleted file span. Cypher is another native Windows tool used by APT. So on the right-hand side, you see a little screenshot from Volexity, that crazy company, incident response company who finds zero-day at large scale. Cypher is used by APTs to cover their tracks. So has the ability to overwrite data that has been deleted so it can be recovered or accessed. But maybe sometimes in different cases, it might be enough that you know that a file was present on disk. Just the proof that a file was on disk might be enough to prove that an attacker was inside your network. You might not have the content of the file, but you can say somebody was there. Let's introduce the USN journal. So the USN journal, that stands for Update Sequence Number Journal. So in the first slide, we saw the master file table. The master file table is our phone book of all the files on our computer. The USN journal keeps tracks of every change inside our computer. When I rename a file, that gets logged inside the USN journal. If I create a new file, that gets logged inside the new journal. So you see, every action I do on my file system is exactly covered and tracked by the operating system. So you see we are heading to, or hopefully you see where we are heading to, because it's really difficult to stay under the radar. Even if you do a slightly modification of a file, that gets tracked here inside that journal. You see here the first red square, that's a service creation. So you see the event ID is 7045, it doesn't really matter. That's just a malicious service created from a real attacker. So I try to publish as much real content as I can. You see that the attacker used a malicious PNG file inside the Windows 10 folder. However, we see that the file landed on the file system exact at that time. Because I have the information from the from the USN journal, from the journal, maybe I can say, I know that a file was present on disk because a service was created on that time. Pinpointing the file name with the sequence number, I can exact say at which time a file was created on disk, even if the file was deleted afterwards, even if I don't have more information. Keep that in mind, we will see later on why it's that important. Again, a purple slide. I, as an attacker, I can easily disable that USN journal. You see the first image from Velociraptor is where I find 24 hits when I'm searching for that particular file inside the USN. If I disable the USN number, I get 0 hits at the USN. It's just one command I have to execute as attacker, fsutil USN delete journal, and every traces are gone. Does that get logged by your EDR, by your CM? Probably not. I'm not sure. Maybe something you want to try out later in the day or tomorrow when you're back in the office. I'm a really, really huge fan of Elastic. If you are following me online or on Twitter or Mastodon or whatever, you saw multiple times that I pinpoint my tweets or that I link my tweets to Elastic's free open source repository with all the detection rules they have. So Elastic also provide CM detection rules, and one of them is exactly this one we see here. So Elastic created a detection rule for exactly this technique here. Again, if you are building in-house rules for your CM or an EDR, if you are having an EDR, this might be a technique you want to check tomorrow or next week if you would see such a behavior here. SRAM. So SRAM stands for System Resource Usage Monitor. So maybe you remember the first slide we saw from Forenzia, cover all the tracks you can. It's really important that you remember it's really, really hard to eliminate and eradicate all forensic traces on a Windows system, even if you trash all the security logs, the executables, the batch files, caches, application caches, shim caches, etc. There might be places you will find traces of that one. And this one here is a really cool artifact. It's called System Resource Usage Monitor. It tracks system and application resource usage. Why is that such a cool feature? You see here, down here, but no traces of write 86 on that host, checked MFT and USN. Master file table, no entries of that file. Update sequence number journal, no entries, no traces of that file. But I found traces inside the SRAM database. So you still have evidence of execution, even if a lot of your common forensic artifacts are not present anymore on disk. I think it's fascinating. I think as a red teamer, you have to really work hard that you can really stay under the radar. Again, it's a red slide here. We can stop that SRAM service, of course. We can do an SC stop, DPS, and then restart the service, and such information as here inside the SRAM database will not get logged again. Then I thought, okay, maybe disabling the whole service might be too obvious. That might trigger an alarm. And then I thought to myself, what about cleaning only certain records in the database? Because I want to be a clever attacker. Zero information in the database, obviously somebody tampered with the data. And then I went to ChatGPT and asked him, hey, ChatGPT, I'm a bad programmer, what can I do? ChatGPT came along and said, oh, okay, that's easy. You want to tamper with the SRAM database, take that code here. And then keep in mind, so the first thing is we have a tables. So a tables array. ChatGPT said, okay, tables, application research usage, network data usage, and then in the upper corner, assuming app name or application ID fields contains the keyword. Basically, ChatGPT said, I'm just skimming through the database. If I find a keyword, psexec, my bad executable.exe, I will just delete it. Enter reality. Okay, no random or no readable content here. The first red corner in the left, on the left upper hand side is the tables which ChatGPT assumed are called application usage, network resource usage. They have other names, and the keywords are not stored in plain text ASCII. They are stored in hexadecimal with a leading 0. So hex number 00, hex number 00. It might be possible to really parse that file. It's not so complicated if you are more skilled, a better coder than me, a better programmer than me. But in reality, I would say even if artificial intelligence is here to stay, you still have to be a good researcher and double-check the result from ChatGPT. So job security for the next few years. It's not so easy as an attacker to fumble with the data, even if you say red teamers will become rock stars because they now have ChatGPT, it's still not so easy. Okay, PowerShell. I think PowerShell logging is one of the most underrated artifacts ever. I keep preaching that over and over again. Maybe also last year here, I presented the gist of 100 or the gist of incident response cases, and PowerShell was also part of that one. Because what we are seeing here is attackers that love PowerShell. Attackers, when they remotely with RDP enters a server, they log into a server with RDP, they start a PowerShell console, and what they are doing, they're typing their information, their commands inside a PowerShell command prompt. What they might not know is that every command you enter will get locked in a file. It's called the console history. And what you're looking at here is from a real incident again, where we see exactly that the attacker is trying to exfiltrate data. So they are storing data in compressed archives to later exfiltrate this data outside of the network. And you see step by step the commands the attacker entered. Red slide, so keep attention if you're a red teamer here. Of course, we can tamper with this information. We can change the paths these log files are saved to. So all your automated tools like Velociraptor and so on, they will try to read the normal path and not from the path you're altered with. So that will fail, of course. This will cause console history to stop receiving logs or just log to a different path. Additionally, it's possible to turn off logging to this file. And I think this might be a command you want to monitor inside your network as well. So if you have an EDR or CM or Sysmon with command line login, SEP-PS read line option save nothing, I would say that's a big red flag for me. Who else does that? Not your typical clerk, your typical secretary or whatever. Or just remove item, just remove the file. So when you're a red teamer and you land on a box, maybe you want to purge that file as well. Just before you leave the host, just don't forget to purge that file. Again, Elastic, I'm a huge fan. I don't work for Elastic. Our customers don't use Elastic, so don't get me wrong, I don't get paid for making advertisement for Elastic, but they provide open source rules. They thought about that process probably longer than you guys did. So what I'm doing frequently, I go to that repository and I browse the artifacts. I browse the source code because I want to learn. Do I know all the techniques? I am able to spot all these techniques, which forensic sources they use to pinpoint that techniques from an attacker. You can learn so much just for browsing this artifact here. And what we are seeing here, they flagging the event action deletion and file name console history. So exactly what we are doing here, just purging traces. You, as a red teamer, might also use this information to adjust your strings so that you can fly under the radar. So when you are purging your tracks or cover your tracks, you might want to have a look here what the blue time might detect. There is also a thing called PowerShell transcript. Besides all these files here, so console history, we also have a transcript files which might log your data. So keep that in mind. There are different places we can find PowerShell traces. What Turla, the Russian APT group, did, they disabled the Windows event tracing. You see here that little PowerShell code. With such little lines of PowerShell code, you can effectively disabling Windows login. It's a super, super effective technique, which doesn't require that much. And you can, with C# or with inline PowerShell, you can run that in your shellcode loader or your dropper. This is one of these techniques you might want to test. So when you are a detection engineer or an incident responder, you might want to check out this technique here. It's still super useful and still used by APTs. Coming back to the talk from Rob Lee, one of his slides was 2 tell signs of timestamping. That technique here is frequently taught and still presented in science classes. They say, hey, time-stopping is a thing, time-stopping is used by attackers. All you have to do is just look for these 2 signs. We see, or if you are not familiar with, Windows have different timestamps. So Windows use timestamps for the file name, and Windows use timestamps for the actual file. So when you are creating a file, Windows creates 16 or more timestamps. You can only manipulate via API the file name API, so on the left-hand side. They say, Rob Lee say here, because attackers cannot modify the file name timestamp, or no, the file timestamp on the master file table, just look out for different results. If the file timestamps don't align, you might have a problem, or you might have timestamping here. Next is these all 0 fraction seconds, they get repeated all over again. Everybody say, just look for that one, that's a clear sign of timestamping. Coming again to Velociraptor, Mike Cohen, one of the core developers of Velociraptor, said, we developed a new feature, it's called suspect timestamping. So you see that little clock here. So when you see that one, you might have a file which was time-stopped by the attacker. In my test, so that's a screenshot from one of my tests from my virtual machine, we see that the birth time is younger. So on the left-hand side, you see the birth time of the file name. So again, Windows keeps tracks of different file time of different timestamps. One of these timestamps on the left-hand side is really the metadata of the file. When was the metadata of the file created? On the right-hand side, we see the timestamping, the time information of the file, the information in the master file table. These files are not, these timestamps are not the same, as you can clearly see. So one was 2 years before. And Velociraptor said, yeah, of course not. I see it that it doesn't align, so I have a problem here. Somebody tampered with the data. And now comes really the funny thing. Fun fact, if you want to timestamp the file name type, all you have to do is just rename the file, rename it back, and then Windows use the time information from the file name and apply it to the file name, so for the master file table. And you have a clearly just timestamp the file. Okay. Now we are heading to the Linux part of this presentation. You see here a slide from Mandiant, the incident response company. They're saying, this is one from January from this year. They say the attackers, after they gain a foothold on that machine, they use dmessage. So dmessage is a kernel ring buffer who holds all the information on your Linux system. They tampered with the information here because they cleared the ring buffer, the dmessage. And you see that this one is a technique used by APTs. So this is not your average ransomware cruise on this was an APT. We can see that here because the first message, dmessage, we clearly see that somebody, me, loaded the malicious rootkit on that server. So you see module verification failed, loading out of 3 module taints kernel. That's a clear telltale sign that somebody was on that server installing something malicious, or at least unverified. The second comment here, you see dmessage -C, and then again dmessage, and you see that all the dmessages were cleared. So I don't have more information. So the same exact behavior as used by APTs here. Funny thing is, we still have that same exact information stored in a plain text file in our server. So you see varlog kern, so the kern.log message still holds the same information as the D message. Coming back to that slide here, even if the attackers clear D message, it doesn't matter. Why it doesn't matter? Because we still have information here, the exact same information. What does this tell us? Because when you don't have that much information about operating systems, about system administrating tasks, you might think it's enough just to clear D message here. No, it's not enough. And that's why it's such a tricky business to be really a good pen tester or a really good APT. Because when you are dealing with a good forensicator, we still have a ton of possibilities to find you in our systems. Same here. Then you come, a clever APT comes along and think, okay, clearing D message might not be enough. Then I'm removing that kern.log file here. Nope, still not enough. Modern Linux systems, they use a thing called journaling or journal daemon. Inside this journal daemon file, you still find the exact same information. So you see, it's really, really hard for an attacker to stay under the radar. Even if they think, I'm clever, I'm purging my tracks, I'm covering my tracks. Nope, still still a lot of possibilities to find you on a system. We see journaling is a really good thing. Then another attacker come and say, okay, I know that you can use the journal. I will clear the journal. Let's see. Again, from Mandiant called it Steel Corgi. And they said, one of the sneakiest comments we notice is the Bleach one. They're clearing various messages, they're clearing various log files. And then they said, it's clear that the usage of the Bleach parameter during intrusion results in hard times for your incident response team. Okay, is that true? Because the attackers here cleared all the authentication log. You see var log auth.log. So every time you log into a Linux server, that gets logged in a log file. The attacker here cleared the log files, and they thought, we are clever, we're clearing our tracks. However, again, in the journal, we see the exact logging information. The IP address, the username, accepted, denied. If you don't know about the journal or clearing the journal, you might still leave traces on the system. Purple slide, we can clear the journal. Journal CTL -- rotate clears all the information in the journal. So if you are doing a pen test and you don't want to leave traces, keep that in mind. You can purge the journal as well. However, clearing logs generates other logs. It's the same as clearing logs in Windows. When you clear the event logs in Windows, that creates an entry that the logs were cleared. When you're clearing the journal, that generates a log, or it generates a log message that the journal was cleared. So again, it's really hard to stay under the radar. When you see such a message here that the logs were rotated or the journal was deleted, you might want to investigate that system. However, who will notice it anyway? Who will notice such a behavior here? Somebody on your Linux server is rotating the journal in order to cover the tracks. I personally, as a detection engineer, incident responder, internal security team member, I would check that, because Elastic Security doesn't have a rule for that one here. It's always about thinking about the gaps, checking the gaps. Do I have missing points as a defender? Keeping, again, on the Linux side here, bash history. You know, Hal Pomeranz, he's one of the legends when it comes to Linux forensics and Linux stuff. And he had a talk also in the SANS Security Summit, and he said anti-forensics. We can just disable the bash history. So every comment you enter in your Linux shells get stored inside a file called the bash history. And then as an investigator, I just can look at the history and I see all the traces from the attacker. Easy enough, right? Anti-forensic here shows us that it's not so easy, or at least Hal said it is easy. When you want to work in our team, we have a little challenge prepared for new employees. One of the employees, Katarina, she's a woman, I'm really proud that she joined our team. I gave her the challenge and I used the exact same comments as here to cover my traces so that while setting up the challenge, I will not leave traces on the box. What Katarina did was she was just dumping the memory from the server and use a volatility plugin to get the bash history out. Because funny thing is, even if you are using a tool or exporting the bash history pointing to null, your comments will be stored in memory. Bash history gets written back when you log out. Until then, it's stored in memory, and we as defender, we can find traces in memory exactly what you did. So all the comments there were my comments entered, and she found it easily. There's a thing or a tool called ProfilProc. It was designed by attackers to search the memory on Linux boxes for clear text passwords, but we as defender, we can use the same tool to dump processes to find signs of attackers, so signs of common strings. I have to 5 minutes left, I know. I have to jump to the next. It will be the last one, so I think I have still time. A stealthier approach, this one is a purple slide. What I will probably do is I would use another shell, like bash, because the older Linux shell, sh, doesn't have a history, and volatility doesn't have a parser for that shell here, so I still comply under the radar. It's really about also, as an attacker, finding the gaps. Last one, 5 minutes, go ahead. This one is really, really one of the coolest things I saw in the recent months, because there is a thing called a dynamic loader within Linux. The dynamic loader is responsible for dynamically linking all your binaries in your program. Funny thing is, I can pass an argument to a legitimate executable directly to the loader, like here. So that lib linux root anti-loader, and the root anti-loader is just my program. And it gets perfectly executed. Why is that important and so useful? Short detour here. I presented in B-Sides Munich last year about /proc. If you haven't seen that presentation, that might give you more background about what I'm talking here. The gist of it is, when an executable runs under Linux and you can delete that file, it's still stored inside the /proc directory. What we can do as blue teamer, we go to the /proc directory and we copy out that file, even if it's deleted. See here, it's just easy enough, just copy out the executable. However, when we do the same, so when we are using our little trick here with the Linux dynamic linker, when the blue teamers go to the /proc/pit directory, all we see is not the actual executable, but we see only the loader. So our malicious tool is not stored in memory, or not easily stored in memory. All is not lost. As blue teamers, we know a little tricks, or a trick more maybe than the attacker. The memory or the executable file, in order to running on the Linux system, must of course be stored in memory somewhere. We can go check the memory regions here, and with a little help from a Python script, we can dump all that memory, reconstruct it in the right order, and we get an ELF file back. So even if the attackers try to be really smart and say, hey, we use a different technique, and the blue teamer will not be able to find traces of that executable, all we can do is Python magic, and I get a file back. And that's it. And 2 minutes, please. If you think that was all basic, I know all that stuff, I'm hiring, we are an English-speaking team. If you want to join us, please feel free, send me a message. Thank you so much.
Thank you, Stephan. I got 1 minute, 32 seconds left. Good work. Yeah, but please find Stephan afterwards if you have any questions. Thank you. And stay put. Don't go anywhere. I see you. You're going. Sir, stop resisting. I'm just kidding. Yeah, it's OK. But please stay put so we can move things along. We're just going to locate the next speakers. They were here a second ago, but I can't see anything. Yeah. Do it.
My LinkedIn profile.
Yeah, just go. Yes, go.
No, I'm fine as well. Thank you for asking. So our next speakers, these crazy kids, and I saw on Blue Sky today that they decided to yesterday go to Stockholm for the day by train, as you do. So that's what, an 8-hour round trip? That's amazing. And I just found out what the reason was, and it was actually to meet the guy who made some of the tooling they're going to be talking about today. And so the topic at hand is incident response, so help me in welcoming Eric Capuano and Whitney. Sorry, I forgot your last name. Champion. How did I fucking forget that? Well, come on stage.
Okay, there it is. Thank you so much for having us. Sincerely appreciate, first of all, the organizers of this conference, because I got to say, in all my years running trainings and workshops and giving talks at conferences, I'm not sure I've ever been taken care of as well as the organizers here. So wow, you've completely ruined me. So well done, well done. And yes, so this is my first time in Sweden, not Whitney's, but it's my first time, and that was the primary reason we submitted the talk. Was it's a bucket list item to come and experience Sweden, and so we're trying to make absolutely the most of it. So yeah, the 8-hour round trip on the train yesterday, worth it. You know, meeting one of our heroes actually that you're about to hear a lot about his work, worth it. So yeah, anyway, so to the topic then. We're here to talk about the just endless number of issues that exist right now for DFIR teams. Even some of the best in the world still struggle with the issues that I'm about to talk about. But I'm not here just to describe the issues that most of you are probably well aware of. I'm here to say that the solution exists now. Sadly, a lot of the solutions and the tools that I'm going to show you don't have marketing budgets, so you might not even know that they exist. The methodologies around those tools you might not be as familiar with. So that's the goal here, is to share some of this. Because Whitney and I have a lot of experience in not only doing security operations, incident response, digital forensics, but scaling it. That's one of the things that I think we have a really unique perspective in. So that's what we're trying to capture here in this talk. So by way of introduction, so my name is Eric Capuano. I've been in information security for, give or take, 15 years, but 15 very dense, very action-packed years. Started my career in the United States Air Force as a cyber warfare operator, and then very quickly started to kind of outgrow the limitations of the federal bureaucracy around the things that we do, so started exercising my skill set in the private sector, supporting also local government, and then moving into actually building a security operations company with Whitney. So she's my partner, my wife, my colleague, my co-founder. So Whitney and I are very much, our introductions are going to be very similar. But we started a company in 2018 called Recon InfoSec, a small managed detection response provider based out of Austin, Texas. So we have a first-hand experience with having to not only do world-class security operations, but to be able to scale it globally. With dozens and dozens of very unique and very specific types of environments. A couple other things that I do, because I'm such a nerd and I'm very passionate about this line of work, is I teach it every opportunity I get. I've been a SANS instructor for about 7 years now, but I also run, Whitney and I both run trainings at Black Hat, Wild West Hack Fest, many different B-sides events, and honestly, anywhere that we are given the opportunity to run a training, we take it. We're actually flying from here to Gdynia, Poland, for ZEEFCon next week. Anybody here going to ZEEFCon by chance? No? Okay, excellent, excellent. So we'll be running a 2-day Velociraptor threat hunt workshop there. So we're trainers, we're practitioners, we're nerds. So we feel very welcome here with most of you. But that's enough about me. I'll go ahead and hand it over to Whitney.
I'm Whitney Champion. I'm very nervous to be here right now. So as Eric mentioned, there's a lot of overlap in our careers over the last several years. But prior to that, I found the security space probably 20-some years ago by happenstance. I was in college and I was running a web server out of my closet, and it got hacked, and I realized I should probably learn how to do this better. So let's go figure that out. So found Linux, I fell down the security rabbit hole, and now we're here. So after college, I started out working for the government as a security analyst for a little bit, and I did a lot of cool projects, learned a lot of cool things, in a lot of very boring rooms with no sunshine and no windows. So I realized that was not the way I wanted to go, and I found the startup life, and we started our journeys together, and now here we are. So a lot of my focus the last several years has been around security infrastructure, automation, and orchestration. So I have a lot of fun building and brainstorming tools that not only make our jobs easier, but allow us to be more effective at our jobs. So I think that's why we're here today. That's it.
Awesome. Okay, so let's get into the problem statement, which I think most of you, especially if you're in incident response today, you're going to be very familiar with some of these concepts. But what's wrong with IR today? Why are we still lagging behind? Well, there's a lot, to be honest with you. There's a lot of issues, but I'll try to summarize at least what I would consider the top 3 that are getting in our way, right? And the first one here is the fact that every IR team I've ever worked with or been a part of had some bespoke, very custom, very, unique approach to IR. And sometimes that's a good thing. Most of the time, it's not, right? Because it's some collection of random scripts that some guy wrote 6 years ago. Nobody else understands how it works, right? So the problem is they're still using duct tape and bubble gum in order to do IR. But it works most of the time. But the problem is there's inefficiencies galore, right, with this process. I've got a couple of quotes up here that you might have heard, right? Like, for instance, if you go to a team of IR folks, ask 5 of them how they do IR, you're going to get 7 different answers, right? Because they all have their own idea, their own approach, their own methodology. And again, sometimes that's a good thing, but most of the time it's not. Because generally there's one right answer, but it's a summary of the best thinking of all the seasoned practitioners on a team. I know the best way to do a triage. You know the best way to do processing of forensic artifacts. Okay, well, let's put these things together and just get overall better. Also, you deal with things like legacy approaches, like using Excel to look at timelines. I mean, it works. We did it a lot back in the early 2000s, but there are better ways. Much better ways. So again, I won't go through each and every one of these. It's really just here to illustrate just the things you hear everywhere you go. We're stuck on the old ways of doing things, and that's holding us back. It doesn't scale. It's not repeatable. It's not reliable. The other thing that I see quite often is heavy dependence on third-party tooling. Now, I'm specifically talking about commercial third-party tooling. And what I hear most often from IR folks is, well, yeah, I can do a great IR only if I have CrowdStrike, or only if I have SentinelOne, all right, or whatever top-shelf EDR, SIEM, product that you have. Okay, that's great, but you're not really doing IR, you're operating that tool now. So what happens if you go into an IR and that tool is not available? It's not reliable, it's not functioning. And it's hilarious that this one's coming up for me because this just happened to a team that I'm familiar with last week. Big IR. Well, the tool was there, they couldn't get access to it. So they wasted many hours not responding to the incident because they couldn't get into the tool that they needed in order to do it. So decoupling ourselves from whatever crutch we lean on and instead being holistic practitioners means it doesn't matter what tool I have. I can do it, right? Matter of fact, I don't even need your expensive commercial EDR because my favorite and most effective tool is free. I'm going to share that one with you here in just a few. But another thing that absolutely drives me crazy is when you're dealing with these commercial paid solutions is, well, what happens when you're in the situation where the CIO, CISO, whomever made the decision to only put the EDR on 40% of the environment because it's expensive? Well, that's okay. We'll just deploy it when we need it, right? Okay, but now I've got to call a sales rep and say, hey, I need another 1,000 licenses like now. Okay, well, we'll send some contracts. Okay, not a situation I want to be in, right? I don't want to have to go to the vending machine to get the fire extinguisher to put out a fire, right? I just need it on hand. So that's one of the other issues that we see. And of course, there's so many others. Like, there's a SIEM, but not all the data's in the SIEM because Splunk's expensive. Yeah. Oh, I should probably watch what I say. They're here, aren't they? Okay. Splunk's good. It's good. All right. Now, another one, and this is one that I'd like to say is getting better, but it really depends on where you go. But it's the dependency on other teams. Okay, so maybe you have a great IR team, maybe you have a great SOC, but you don't have control of the firewalls, maybe, right? That's some network engineering team somewhere in IT. So what happens if I'm in a fast and furious fight with a threat actor in an environment, and I've collected up all the network-based IOCs? Well, I'm ready to start taking, remediative action. But now I have to submit a ticket to the IT team. And they work on different hours. They work on different SLAs. My emergency is not their emergency, right? And so removing any dependency, removing any bottlenecks to the speed that I need to move, because the threat actor is already 16 hours ahead of me, right? I cannot afford to lose any additional time by having to depend on other people who are not moving at the same speed that I am, right? So again, just summarizing some, there's obviously countless other examples of things that get in our way, but these are the ones that I see most commonly and the ones that we have had great success with solving. But I couldn't not use this GIF because it's basically the same concept of the Jurassic Park scene, right? Where the park is coming undone, the dinosaurs are getting out, and they're trying to fix it, but they can't fix it because the only guy that can has gone rogue, right? So they're trying to, put the velociraptors back in the pen, and IT once again doing what IT does. I kid, IT is obviously the glue that holds all these things together, but I don't want to be at their mercy in an emergency. So the next thing is not being completely honest with ourselves about how efficient we are. Most of us have the academic knowledge. If you're in IR, I have no doubt you've seen this diagram before, right? This is the 6-step pickerel process that a lot of us like to use. There's others like it, but this is one of my favorites. Okay, so we understand academically how IR should flow, right? We know that we're in the preparation phase. Right here, as we sit listening to a talk, we're preparing. If we're in the incident response field, we're getting smarter, we're getting better, we're learning about new techniques, et cetera. But really, where most of us spend our time, when the thing goes boom, we spend it in these 3 steps right here. That's where most of the actual hard work happens during an incident. Okay, but we're familiar with the concept, but how efficient are we at it, right? And that's the thing that a lot of folks don't want to talk about. Because when you really get down into it, it's like, well, I don't know, we take about 14 to 48 hours to do that part. Or sometimes a week to do that part. Okay, well, in the case of a ransomware event, you have minutes or hours. So if you're not measuring the performance of your incident response process, well, how do you know if you're getting better at it or not, right? So that's the other key here that I want to emphasize. And like I said, so even though of the 6 steps in Pickerel, really during an IR, we only have to worry about these 3 right here. Those are the hardest ones. Those are the ones that take the most time. Identifying the issue, but then digging in, scoping it, trying to understand how big it is, how widespread it is, where's the threat actor, where are the persistence mechanisms, all those investigative questions that we must answer. Because eradication, not an option until you've fully figured out the scope of the breach. But if your tooling is holding you back, if other business units are holding you back from answering those questions quickly, well, then you're just pushing that eradication step out further and further and further. And I don't know if you follow the trends, but Mandiant, the M-Trends report, which has been coming out since like 2011, they report this concept of dwell time, right? The amount of time a threat actor, on average, is observed inside environments before they're detected. The number's been going down a lot. I think it's down to something like 11 days as of the last report. But one of the major drivers that's taken it from over 400 days to 11, it's not that blue teams are just getting that much better. It's that threat actors are moving that much faster because they know that the clock is ticking. So they're not dwelling like they used to. They're getting in, they're wiping your backups, and then they're destroying the environment, or they're exfilling the thing, or they're doing the thing. So the point I'm making is they are moving faster. So if you're not, it's not going to be a good time, right? So I'm just trying to emphasize the importance of speed here. Because to visualize this, say you've got your standard textbook attack chain up here. Well, from our perspective, the attack chain starts here. That doesn't mean that's where the attack started. That means that's where we first became aware of it. We've identified, hey, we've got suspicious PowerShell running on one of our production web servers. Okay, well, we've got to start to wrap our arms around that. You know, how bad is it? Is it on this one system? Is it on many others? That's our scoping containment. And so generally, most often, you're here for a fairly long period of time. That's in that pick-and-roll process where we're iterating and iterating and iterating. And the reality is, this is where we want to be. That's where your business wants you to be. That's where your boss wants you to be. Just get rid of the problem, right? Kick them out, re-image the box, whatever you got to do. Just make this problem go away. But the reality is you can't shortcut. You can't fast track to the eradication. If you do, you play this endless game of whack-a-mole, right? So the point is, this part right here is the most critical to make sure you can actually do a full eradication. You have to understand how big the problem is before you can solve it. So how long does it take you on average to get from identification to eradication? Because if you're measuring that in days right now, you are way behind the curve. Because the reality is, if you're dealing with these hyper-aggressive, fast-moving threat actors, which most of them are now, well, they've got the head start, right? They're pulling the trigger in minutes, and best case, hours. But most teams are still struggling to get here. It's taking them days, if not weeks. So, all right, I think I've made it clear that we suck at IR sometimes, right? But that's okay, because we've got solutions. So there is a solution or a combination of solutions that we have found great success with in solving every single one of those issues. So it's going to cost you a lot of money. We're here to pitch the magic to you, but I'm just kidding, because everything we're about to show you is free. Sometimes that is the coolest part about this industry, is that the best things are often free. The problem is you don't hear about them because they don't have marketing budgets. They don't run booths at conferences. So let's start with a couple of the technical pieces of this, right? Some of the technical pieces that are slowing us down. It is this fallacy, this misconception, this old school habit of thinking that anytime I do IR, forensics, I need full disk images of everything, right? Wrong. Now, for the few of you maybe in the room that work in law enforcement, or you do criminal investigations, that kind of stuff, you already know what your requirements are. I'm not talking to you. I'm talking to folks that are embedded inside of enterprise organizations, folks that are doing breach investigations, where, let's be honest, you're not going to court. You're not going to go and testify and prosecute some North Korean threat actor. So at the end of the day, I do not need to abide by the ancient way of doing forensics, where I'm taking full disk images of 2 terabyte systems, because that alone is going to increase the gap between you and the threat actor by days, by holding yourself to this artificial requirement that I need full disk images. It's simply not the case. There are a few rare situations where I say, well, you might want a full disk image. If, for instance, you're dealing with anti-forensics, which the last talk was on anti-forensics, right? So sure, there are scenarios where full disk sometimes helps. I'm going to tell you right now, I can count on one finger the number of times I've needed a full disk in the last 5 years. So the real answer here is modernize so that you're not adding artificial constraints because you're adhering to something that doesn't even make sense for your specific function, your role. And one of my favorite ways of thinking about it is apply Pareto's principle to it, right? Because generally, that 2 terabyte disk that you would have made a 8-hour bit-by-bit copy of, turns out there's probably only about 4 to 5 gigs worth of critically important data on that disk for you. The forensic data, the things that we already know we need, registry hives, event logs, prefetch, all that good stuff, yeah, that's like this much stuff. So why would I need this much data to get this much stuff off of it? So the main driver in speeding up at least the initial phase of incident response is migrating to what we call triage acquisition, moving from full disk to triage. And triage simply means, instead of taking the full 2 terabyte disk, I don't even need 90% of that data, I'm just going to get the stuff I care about. Well, that kind of implies, though, that you know what stuff you care about. And that's a long list of things. The good news is you don't even need to think about it anymore. Triage acquisitions are so common, so popular, this is the way it's done, that you have multiple tools ready to go, free tools, that know exactly where those files are. You can extend it, customize it, make it do whatever you want, but the point is, this is the way. So triage acquisition, great, got it. That's not actually rocket science, but it's how we start to move fast. So the first tool I want to share with you, and I'm sure many of you have probably at least heard of it, I'm sure several of you use it, one of the coolest tools to hit DFIR in many, many, many years is a tool called Velociraptor. It was created by a former Googler by the name of Mike Cohen. He's an Australian software engineer. And Mike originally was the architect behind GRR, Google Rapid Response. And he realized some of the limitations, some of the issues with GRR. He's like, OK, this thing is powerful, but unless you have like 4 full-time DevOps people, don't even think about it. It was complex. It was difficult to maintain. So he said, I'm going to do this differently. And so he started work on Velociraptor and basically took all the best parts of GRR, left all the things that people didn't like, and he created one of the most powerful yet easy to use digital forensics incident response tools that's ever existed, and it is free, and it is open source. Now, some years ago, Rapid7 realized, ooh, this is hot. We want this. And they acquired him and the project. But I will say Rapid7's got a pretty good history with maintaining open source tooling, like Interpreter or Metasploit and that kind of stuff. And they've made good on their promise to Mike that we're going to keep this thing open source, and we're going to actually add resources to help you continue building and supporting it. And so it's only thrived since the Rapid7 acquisition. So Velociraptor, I could spend the next 3 hours just talking about how awesome it is. Obviously, I don't have time for that, so I'll just tell you this. This is my go-to triage acquisition tool because it is wicked fast, it is scalable, it has a client-server architecture, so I can pull triage acquisitions from an airplane, from systems that are on the other side of the world. And it's going to work, it's going to be reliable. Furthermore, if you really want to get into it, Velociraptor doesn't even need a triage acquisition because it can do forensic data parsing on the box itself and just return the post-processed output of those artifacts, which oftentimes is actually really what I need. But if I need the triage acquisitions, Velociraptor will take them. It'll run on all major operating systems, Mac, Windows, Linux. It is fast, it is performative, it is secure, it is extremely powerful. Because I can use Velociraptor from A to Z of an entire IR, from the triage acquisitions to knife fighting with an adversary. So you name it, it can do it. And yes, it's more powerful than your really expensive EDR tool. But it has a different set of skills, though. I will say it's not a replacement for your EDR, but it is, in some ways, much more powerful. It's got a fairly intuitive, easy-to-use web interface. You stand this thing up, which, by the way, you can deploy Velociraptor in about 5 minutes. I don't care if you have 50 systems or 15,000. 5 minutes, you'll have this thing rolled out. Both the server and the endpoint agent are single binary. So you could stand up this server with one command. No complicated apt-get install nonsense. It's one command, boom, you have a server. And you take that binary and deploy it to your endpoints, and now you've got agents. And now I can set up hunts against all those endpoints, whether I'm just simply looking for an individual IOC, a specific artifact, or I'm running triage acquisitions on 500 systems. OK, push the button, go. It's going to happen. It's going to work, and it's going to do great things. So one of the ways we approach this is when we know we have an IR, we use the labeling system in Velociraptor. So we just slap a label on the box. Right there in the UI, we say, this box compromised. That kicks off automations on the back end that say, oh, OK, well, if it's compromised, then let's take triage acquisitions. So it just basically starts to speed up the process. Any analyst on the team can go in and apply that label, and it's going to immediately kick into action all the things that we know are our best practices. Take the triage, send it off for processing, et cetera, et cetera. You're looking at me like, oh, time? Oh, are you kidding me?
It happened fast.
Oh, my gosh. OK, I'm going to speed up. I'm so sorry. What's our cutoff? What's our drop dead? Are we at it? No. OK, you scared me. OK. Whew. That look, you scared me. OK. All right. So anyway, I will pick up the pace only because we've got several things I want to talk about. If anybody wants to expand on this stuff, we're happy to hang out and chat. So Velociraptor, it's awesome. It'll run my triage. It's using the Cape open source Cape target files, which, if you're familiar with Cape, it's the same thing that powers Cape, which is another triage acquisition tool. Velociraptor does it better, but that's OK. We love Cape too. But yeah, you just set up that triage. You say, here's all the data I want to get. Well, Eric, I don't know what data I want to get. Well, you don't really need to worry about that because you can just use the built-in presets because we know what we want to get, and we contribute to those presets. And so you could just pick one of the base sort of target configurations, say, I want to get all the stuff. Just get all the stuff. OK, it'll get all the stuff. It's still going to save you a whole ton of time. And if you're curious where the stuff it gets comes from, it's open source. Eric Zimmerman has a GitHub repo called Cape Files. You can go and read in very clear YAML format all of those targets that inform Velociraptor and Cape where all the best forensic data is. What I love about this is it's open source, it's easy to use, so many practitioners contribute to it regularly. The screenshot I chose up here was intentional because it's Whitney's. So we did an incident response some years ago on Manage Engine, and we happened to discover at that time that there's a default location where Manage Engine writes its logs. I didn't know about that before because I never used Manage Engine. Well, now I know because I just did an IR. So we contribute that back to GitHub, and now every practitioner from this day forward that does an IR with Cape or Velociraptor will get Manage Engine logs. It's just cool, right? So we're all bettering ourselves. We're raising the bar collectively by contributing to things like this. OK, great. So kick it off. Velociraptor goes, gets the data, brings it back. And it's up to you to do what you want to do with it. Now, next tool, Hayabusa. So Hayabusa is a product of Zach Mathis, who's a SANS instructor as well, but he's based out of Japan. He's part of an organization called Yamato Security. Hayabusa is one of the coolest event log parsing tools that's ever existed. There was one before called Chainsaw. This one's faster. This one's better. This fits into the puzzle because when I drop into a customer environment to do an IR, there's like a 95% chance there's no seam. There's no place to go and look at alerts. Okay? So how can I get retroactive threat detections when there was nothing in place before I walked in? I'm going to do it with Hayabusa. Because here's the thing. I've already collected all the event logs from every system in about 5 minutes flat. Well, now I'm going to use Hayabusa to analyze all those event logs at scale and get retroactive detections based on a corpus of about 3,500 threat signatures to include Sigma from GitHub, Florian Roth and his team, but also Hayabusa has its own detection logic built in, and it is fast. It's written in Rust, it's multi-threaded, it is incredibly fast, very powerful. So effectively, all you have to do with Hayabusa is aim it at some event logs, right, wherever those are. Well, if I already did my triage acquisition, that means I've got them all right here. So I run Hayabusa against it. It's going to do some really cool parsing and analyzing and based on the detections that I've enabled or disabled, and it's going to generate some output files. CSV, JSON, or just send it right into Elasticsearch or Splunk. And now I have a seam retroactive. As far back as those event logs go, I now have detections for those events. So pop it open, find the threats. Cool, right? It's like going back in time and deploying a seam. I'll take it. Now, I'm moving quick for a reason because we're not even at the best part yet. So Plazo, it's the next piece of our toolkit. Open source tool, one of the most powerful open source forensic tools that's ever existed because it is basically the kitchen sink of forensic artifact parsing. Another free tool. Written by Christien, I'm not even going to try to, Gudjonsson, I'm sure someone here could probably say it better than I am. He was a Googler at the time when he created Plazo because he saw a need for a consolidation of forensic artifact parsing. We used to use 47 different tools to process evidence. And he said, what if there was one that could do all of it? And he made it. And now that still rings true today. So take your triage acquisitions, run them through Plazo, generate super timelines of every single thing that's ever happened on that system based on the evidence that you have. OK, that's pretty cool. I can throw anything. I can throw raw event logs, registry hives, prefetch files. It doesn't matter. It'll parse it. If it's forensically valuable, Plazo knows how to parse it. And it's going to convert it into temporal timelines to show you the most granular bit of detail about what unfolded on a system. So when you're trying to trace threat actor activities, figure out initial access, lateral movement, it's all going to be in that timeline. It's pretty powerful stuff. Again, it's free. Now, TimeSketch. And yes, these all tie together, so bear with me. I'm not just throwing random tools at you to overwhelm you. All of this is about to tie together. TimeSketch is a critical piece to the puzzle. Yet another open source tool. If you've used Elastic, Capuano, and all that good stuff, well, TimeSketch is that, but built for forensics, built for timeline analysis and collaboration. So what I'm able to do is take all that great stuff I got out of Plazo, send it into TimeSketch, and have the ability to collaborate with an entire team on those timelines. Let's all look at them together. Let's all annotate what we're seeing. Let's all, dig in and find where the bad guy is. So I can also, for instance, apply Sigma detection rules against those timelines, which is kind of cool. But Hayabusa does it better, faster, stronger. So just bring the Hayabusa outputs into TimeSketch as well. And now I've got all the timelines and the detections. Graph your logins, graph your visualizations of what's going on across the systems. It's awesome. All right, so that sounds like a lot of work, right? all these free tools, they're only free if you value your time at nothing. So what if we had SOAR for DFIR, right? Automation. Just push a button, deploy it all. That's where the next tool comes. So OpenRelic, and by the way, TimeSketch and OpenRelic, both written by Johan Berggren, who's based right here in Sweden and Stockholm, created OpenRelic to solve that problem. What if we had an orchestrator, an automator that could do all these things magically? Just like SOAR does for the SOC, we need the same thing for DFIR. It's exactly what OpenRelic is. It's a container-based platform that essentially just Dockerizes all the different tools that we use in an IR and just basically sends it through a workflow, just like SOAR playbook. So you can sit there and build out the workflow to do anything that you can imagine. And if there's something you want it to do that it can't, OK, it's a Docker template. Create a new container and then run whatever tool that you want. And you can visually build out that workflow. So I can say, hey, look, if I ever give you a bunch of EVTXs, we're going to send those to Hayabusa. We're going to also send them to log to timeline. And we're going to export those to CSVs and send them to TimeSketch. It's also got a very large marketplace of other capabilities. So you want to pull down a new tool, a new feature, whether it be Floss or CAPA or whatever forensic tool you like. It might exist. If it doesn't, submit a PR, add it to the marketplace. Cool. This is kind of redundant. It's just saying that one of the other cool things I can do is in OpenRelic have a worker that also will send things to TimeSketch. So now we're starting to tie them together, right? It's kind of the benefit there. All right. One last thing on OpenRelic is the fact that it's now powered by AI. So if you have seen the magic of using LLMs to add analyst enablement or decision enablement, that's now a feature. So we can start to interact with our forensic data right there inside of OpenRelic using whether it's local AI that you have, local LLMs, or you hook it into Claude or ChatGPT or something like that. And one last thing, and I'm going to shut up because I've been talking way too much. We got to go meet Johan in Stockholm yesterday, so just a little quick. That was a fun adventure. There's Whitney up there showing him the stuff that she's built, which is coming up. So I'm going to go ahead and hand that over to Whitney, because that was a lot. I don't expect that you retained everything I just said to you, but I will show you this. This is how we tie them all together and make this much more accessible, because that's the only problem with all the tools I just shared with you. They exist, but you got to have a little wherewithal, a little bit of DevOps knowledge to deploy them and use them. Well, Whitney is my magician to make that a lot easier, because I need things to be easier. So, all you.
Eric just likes that last slide because he gets to call me a tool in public. That's all it is. So what if we could simply install .sh? Wouldn't that be great? So one of the cool things is all of these tools are already pretty simple in and of themselves. So Eric dove into all of them, but Johan has taken great care to make sure that OpenRelic is easily deployable. Yes, it's like 75 containers, but you can deploy it with one script. Same with TimeSketch, Velociraptor, one binary. All of these things are simple in and of themselves and easy to deploy, but none of them really know how to talk to each other without some fine-tuning and configuration. So we wanted to make this approachable, repeatable, scalable. I don't know if any of you are familiar with any of the talks that Erica and I have done in the past. Back 4 or 5 years ago, we gave a talk on something very similar. It was before OpenRelic was a thing, before it existed, we built a very similar pipeline that was taking triage acquisitions from Velociraptor and getting them into TimeSketch in a very repeatable, scalable manner. So we took it a step further this time. We love OpenRelic. We love what Johan is building with it, and we wanted to integrate that into our pipeline because it's really powerful. It bundles up all of these other tools and makes them stupid simple to use. So what we've done is basically built one pipeline to bring all of these tools together. So it integrates Velociraptor with OpenRelic, which ties up all those workflows for you in a nice little bow and shoves them into TimeSketch. So within minutes, effectively, you can be staring at hundreds, if not thousands, of timelines, depending on your workload. One install script to install it all. You can deploy it on-prem or in cloud, and then the more CPUs you throw at it, the faster it goes. So that's fun. We also built a few Velociraptor artifacts to basically enable this entire flow from start to finish. So you go into Velociraptor, it's going to go watch for those CAPE triages that you've deployed across your fleet. as Eric mentioned, the cape files goes and collects all of these various pieces and parts that get bundled up into a zip file, and then we send them into OpenRelic to do the processing, and then those get sent into TimeSketch or not, depending on where you actually want them to go. You can configure all of that as you need.
So the coolest part of this, and just to recap, in case it wasn't clear, if you go back one slide, what Whitney has built is specifically the OpenRelic pipeline project. And this was meant to be the bridge to take the best tools, the tools that we live and die by, bring them together into a single Bootstrap installation. So you can run the script and have all those tools not only deployed, but now they're all directly now integrated. You push a button, magic happens, which is kind of cool, right? Now, for power users and people that have the wherewithal to build their own workflows and automations, just use that as a template. Use it as inspiration. But for those of you that are still using Excel to look at timelines, this would be a good place to start, right? All right. So, so the cool thing is in our benchmark testing, what we were able to prove out using this workflow is, hey, I pull event logs through Velociraptor. 4 seconds later, I've got Hayabusa CSV timelines ready to go. 4 seconds from the minute I've told Velociraptor to go get the event logs, I come back and I've got, the processing time, but I've got timelines and Hayabusa outputs for event logs. Okay, well, what about something a little bit bigger? Oh, I'm sorry, I misspoke. 5 to 30 seconds for Hayabusa, 4 seconds for the collection. My bad. I know, it's a long time though. 4 seconds to collect them, 5 to 30 seconds to process them. Okay, that's fine. And then another 5 to 30 seconds, hey, to send those timelines to TimeSketch. Okay, but let's just add all that up. What are we talking about? A minute. A minute. And now you have the most important part of your investigation, the full picture of what's going on, right? So what would previously have taken us hours and hours, right? We're down to minutes. And great, you want to do that against 100 systems? Those jobs run in parallel. Go ahead. The only limitation there is how much CPU are you throwing at this thing? Because it'll use every core that it has. So we stand this up on some massive EC2 instance when we know we got a big one, a big breach. Okay, throw 32 cores at it. And it's going to rip through that data as fast as it possibly can. And it can handle it, right, in parallel. So go ahead, Whit. Oh, right. Best part.
Yay. I don't know if we have time. Do we have time?
Do we have time?
Do we have time? Yes? Okay. So we recorded a demo just in case the demo gods frowned upon us today. So we have that as a backup, but we're going to try to do it live. So where is your browser?
Yeah. This tab right here. It's got your stuff. I know. That's why I was going to. There you go. Whoops.
That's not it.
Why is it not letting me?
It's not on the screen.
I know. I got to switch it to duplicate. Stop. Stop embarrassing me in front of my friends. Okay. There you go.
Yeah. Oh, I got logged out. Nobody look. Oh, yay. All right. Oh, that's fun. You're making me Windows. I don't want a Windows. All right. So, step number 1, make sure our client's there. Cool.
So we're in Velociraptor right now.
Velociraptor,
For anybody unfamiliar.
All right, so typically the way we've done this in the past is we slap labels on any Velociraptor clients that come in just so we know what IR or what customer or whatever they belong to. So in this case, this host belongs to IR1 just because this is a demo. All right, so we are going to go kick off a really stupid simple cape triage collection. I'm not going to do the full thing because those can take a while. I'm just going to go in here and do event logs because that's all I really need for purposes. Event logs. All right, turn that on, make sure it looks good, mash the button, wait a few seconds for this to bring those back, and while it's doing that, I will go over here and show you what it's actually doing in the background. So we've got what are called server event monitoring artifacts configured on Velociraptor, and this is part of what we added to the pipeline. So these are effectively just watching for that cape triage to finish, so it knows when it's done, it goes and zips up all those files, and then says, hey, go point at this API. So all of these are getting kicked off, so we should be able to go over here to OpenRelic, refresh this guy, and we should start seeing, yep, there we go. All right, so Plazo has started. Hayabusa should be following behind it. If you go in here and click on the workflow, you'll see that it has already created this workflow based on the triage file that we uploaded. It's going to pass that on to Plazo or log the timeline, and then it's going to ship that over to TimeSketch for us. So we don't have to touch anything other than kick off a triage, and even that part can be automated, and that'll be the end of it.
And I just want to call out that, so this specific workflow that you see here, identifying the fact that we have event logs, well, we know that generally what we want to do with event logs is we want to super timeline them, and we want to hit them with Hayabusa. Well, you wouldn't even need to come up with that workflow yourself, because that's what Whitney's middleware is doing. It's saying, oh, I know what to do with this. I'm going to use this template, this workflow. I'm going to just kick it off, run it for you. But if you want to customize and configure it and have it do other things, you absolutely can. But right out of the box, it's doing probably one of the best things you could do with that data. And all of this is open source, so you can go modify it however you see fit. Give it back, contribute back if you feel like it. It's totally open. So it has generated the Hayabusa timeline. So now it's going to pass that to TimeSketch. If any of you are familiar with Plazo or Hayabusa, Hayabusa is always super fast, and Plazo can tend to take a little while, especially because I am cheap and I only threw 2 cores at the system. So it's going to be running for like half an hour, and I'm not going to keep you all here. But this should have a Hayabusa timeline in it. There it is, right there. So it's already done. And that took, what, less than 5 minutes? So we've got a timeline sitting there staring at us, and then Plazo should be, it'll be done in a little while. The demo, I cut out the waiting part, but typically if we throw 32 cores at this thing, it'd be done by now. So yeah, your mileage may vary depending on your cloud spend and how much you give it. It can take a little bit longer, but we have data. So all the projects that we shared with you are open source, easy to find. The one net new here, the one that we wrote, or the one that Whitney built specifically to power this talk, is on our GitHub as well, which the link was a few slides back. We'll drop the slides. We'll post those on Blue Sky. But yeah, if you want to pull it down and check it out, Digital Defense Institute, Open Relic-Pipeline, it's your 0 to 60. You know, run a script, have all these tools integrated, ready to go, and this is our favorite approach. So, yeah, happy to answer any questions, but I know we're probably at time. So,
that was amazing. Those are some really cool tools. I'm sure a lot of our viewers here, participants, will find some good use for them, I think. Do we have any questions in the crowd? Do I see any hands? No hands? Well, you can always find these guys later. You'll be around, I hope.
Yeah, you bet.
Great. And then I think it's just about time for a little bit of a coffee break before our final talk for this year's con. So see you in about half an hour. Thank you. some coffee and some cake. I saw there was tiramisu. That's amazing. We're ending Security Fest after this talk, but we're rounding it out with some more great blue team stuff. Specifically this time, we're going to be delving into some threat intelligence. And the man to help us do it, to my right, is Chandler McClellan. Please get him on stage and give him a hand.
Done this beforehand. I always need water. Can we just give a round of applause for the amazing Security Fest people here? This is the coolest conference I've been to in a long time. Day 2, amazing villages, amazing communities, amazing speakers. I love it. It's the first time I've been to Security Fest, and I've loved it. It's a lot of firsts for me, actually. My first time meeting Swedish people. That's been very new for me. The stereotypes, not all true. I mean, yeah, a lot of very tall, beautiful people here. I was like, oh my gosh, America, what are we doing? We need to pick it up. But Sweden's been amazing. I've loved Sweden. I've loved my time here. What they don't tell you about Swedish people, I found out, is you guys have superpowers. Nobody talks about that. But every day, I've been here since Sunday, in the morning, in the afternoon, in the night, whenever I'm awake, there are people partying nonstop. You people have been partying for 2 days straight. Drinking and going. When do you people sleep? It is amazing. Anyways, I love it. I'm happy to be here, and I'm so thankful for this opportunity. It's super cool. So, hopping into it, a little bit about myself. I always forget to start a timer. So, my name's Chandler. A recent graduate from university, just a couple months back. My mom is very proud, so very excited to finally be a real adult out here hanging out in the world. My first time to Sweden, obviously, so a lot of my camera roll looks like that, me making the same face as I walk around Gothenburg, going, oh, wow, building, beautiful park, I love it. But it's good stuff. It's very fun to be here. I'm a senior consultant at a company called Coalfire. I do a lot of work in dark web monitoring, threat intelligence, and some threat hunts for different clients and customers. So that's a bit of my background in cybersecurity, and I love speaking. I really enjoy it. You can see me giving a briefing at the Pentagon this past December. That's actually a lie. Well, that's 2 lies. I don't love speaking. That was the first lie. I just like coming to conferences and meeting cool people and cool friends. And the second lie is that's not a real briefing. It is the Pentagon, but those are just my friends pretending to let me give them a little briefing. So you meet really cool people in cybersecurity, and it's one of my favorite things. They let you do dorky stuff in important military buildings. So that's a bit about me and my background. Let's talk about the divide here, right? What is that gap that we are trying to hack? What is the goal here? For large enterprises, right, they have dedicated threat intel teams. They've got big budgets. They've got advanced tools. Whereas, the smaller organizations, they're working with, little or no full-time CTI staff, minimal budgets. So, like, you see, the big FANG companies, you got your CrowdStrike, your Microsoft, your Google, your Apple. They've got all the money to throw at a problem in the world. They have millions and millions of dollars they're actually spending on just cyber threat intelligence spread across some different teams. In the modern meme sense, they are 100 gorillas where we are the one single human, right? We're going to be creamed by them every single time. And it's not fair because we face the same threats, but we have unequal defenses with it. Small teams, we also face the same nation-state actors, cybercriminal threats, whatever you have it as the big players, but we just don't have those comparable resources. Over on the right, my time, I worked at CrowdStrike previously, and it was one of those situations where every tool you could ever want, every hour of the day you wanted to spend chasing threats, it was there dedicated to you, and you had that support. You felt like, the Knights of the Round Table. I've been at other companies and helped other organizations stand up intelligence teams, and sometimes it feels like Monty Python. I don't know if that's a movie that's popular here. Last night I saw a lot of very niche cultural references here, so hopefully you guys got, they're just, this poor King Arthur did not have the luxuries of the money. They had the coconuts for horses and stuff like that. So you're very scrappy, you're on a budget, but they got by and they did well. So why do we care? Why do we care about this gap? Why don't we just say, whatever, let the big dogs worry about the important cyber threat intelligence. We'll just not deal with it. We'll not worry. Well, threat actors, they target organizations of all sizes. Unfortunately, it's the small businesses that often suffer. You know, over half of the malware attack victims that we see are small businesses. So CTI is important because it's a force multiplier for these people. 87% of organizations report that cyber threat intelligence improved their prevention, detection, and response capabilities. And the smaller teams, they had slower detection and response capabilities without that CTI component, even in a very immature phase. So there's real business impact to it. It is not just a simple cost vector that people are going, oh, maybe we can turn it into marketing or do something. It really does informs defenses in places where you're lacking intel and helps you with undetected breaches, costly incidents, strategic blind spots, et cetera. So let's look at the industry adoption real quick. Going into the 2024 SANS CTI survey, they have a bunch of different data points and interesting things you can look at there to understand the industry adoption and why it's become such a prevalent thing. Most orgs are obviously embracing CTI. Over half have clearly defined threat intelligence requirements in 2023, and only 3% of organizations surveyed didn't have any plans for CTI. So everyone's kind of thinking about it, they're trying to work on it, and that's been on an increasing trend for adoption, and also those that are deciding, okay, this is something we need to step into. So yeah, leadership's on board, they're finally coming around. Over half the execs are getting behind it, and it's not just this boardroom topic anymore that is kind of brought up once in a while. There is real measurable effect from having actionable cyber threat and intelligence at your organization at an organizational level, not just industry-wide. So it's not just a nice-to-have thing, and a lot of people that didn't early adopt the CTI hype train as it came through, they're starting to find ways to try and catch up and have this capability. So value add-wise, go down that list and read them. I can't count higher than 10, but it looks like a lot. There are so many different uses in your organization for cyber threat intelligence, and it hits on a lot of the big ones, but it just provides context and background and understanding. When you look at what intelligence is used for, it's both used for, okay, let's give context and understanding for what we're trying to look at and understand in our environment, or perhaps something that you need to be looking for and you're missing. It helps with visibility and also hunting. It's kind of the sides of the same coin, and it's used across multiple security postures and disciplines within the organization. So what kind of data do these important people want to know about? These C-suite people, the people that go, okay, I'm buying in, cyber threat intelligence sounds important, give me all of it, right? They're sitting there going, I want to know the dark web, I want to know all the social media posts, I want to know the sentiment analysis. I want to know, just what leaked credentials are out there. I want to know where we're sitting at right now with our partners in the industry, with people that we're up against. What are they seeing? What are they knowing? Like, if they're going to do it, they want it all. And they have a grocery list so long that it'd probably scare most people to death if you're just approaching this for the first time. And that's really the big first problem that we come to as a challenge for small CTI teams, is there's so much demand here, but we aren't getting any of that resource and support off the bat. Sometimes we go, how do we go about this? We don't have the experience, maybe we don't have the management buy-in that we need, and maybe we just don't have the budget, the resources and funding, if you're a very small team and this is just a partial implementation that you're rolling out. So yeah, limited budget, obviously, probably the #1 inhibitor to an effective CTI team. Small orgs, they really struggle to find the ability to afford those commercial intel feeds, right? They seem really good. These big vendors are always putting out these amazing reports, but they charge a lot of money for it. And you're going, okay, what is the value add? Are we going to get our bang for the buck out of this? Skills gap, that's another thing. These organizations invest so much money into training and analysts and programs to really refine that and try and produce that high quality actionable intelligence. But for a company that just needs to do this for themselves, sometimes you're kind of at a loss for how are we going to do that? Maybe we're splitting roles. Are we still being able to juggle our regular responsibilities and duties and kind of add in this aspect of cyber threat intelligence to improve our defenses? It's a lot of give and trade, as well as there's just different tools for cyber threat intelligence that you might not be familiar with, different processes, automation, all the things that kind of stack up behind that. And of course, management buy-in. I've said it once, I've said it 1,000 times, this is always the one that it comes right back around to, because management are the people that give you the time and the resources, people and people and money to accomplish this. So it's a really difficult situation to be in for our small teams. So pivoting a little bit into what we're doing here. What is the mission? I was a little inspired by the fun quiz game that we did last night and all the different task force and stuff. So now we're going Mission Impossible theme, because sometimes it feels like an impossible mission to hack the gap in CTI, to overcome this divide between a small player and what the big companies are able to do. So with every good mission, we have our goal. And our goal is to empower the small security teams to achieve impactful and high-quality CTI without those FANG-level resources, right? If the answer was just spend more money and have more people, well, then everyone would do it. But that's not plausible. That's not a possibility. So we're going to cover a few key strategies, how to bridge that gap, optimizing and getting good at open source intelligence information, how to do that in an effective way. Super, super important, because it's kind of like that free one out there if you can do it right. Automation, how to kind of scale it up and gather that intel and kind of punch above your weight. Turning data into actionable insights. This is just what processes do you put in place, what kind of frameworks and methodologies are you using to make sure that you are ending up with good quality intel that leads to action and drives that within your organization. And then fostering collaboration. I mean, at the end of the day, internally or externally, wherever you're doing this, you share that intelligence, you share that work to multiply your capabilities. So we're starting at the beginning, the super simple. Just what is CTI, right? CTI, I mean, it was that cool word for a while back for CISOs, before LinkedIn came all about the whole AI train and all that hype. People were all talking about CTI, and it was kind of the new buzzword. It's really simple. CTI defined is analyzed information about adversaries that informs cybersecurity decision-making, right? It's not just raw data. CTI it's not feeds, it's not IPs, it's not these fancy reports on APTs. At its core, it's just a process of turning raw data into contextualized intelligence that's actionable. So it's going to inform those security controls or strategy at your organization. So there's a few different levels of CTI. You can think strategic, this is the big picture, C-suite kind of level informative stuff. There's operational, where you're kind of studying different campaigns or activity and clusters in the industry. And there's also just tactical, simple intelligence that's like IOCs and different technical data that you can feed into tools or give to your security analysts to be on the lookout for as they're working. And we have to kind of cover all three of these fields as a small organization, and it's a lot. It's a lot to do, but if you're focusing on the quality of your intelligence, it's a very natural flow to be able to produce these three different subtypes of intelligence, or to meet these three stakeholders' needs. So, starting with the big picture, this is the whole goal of CTI right here. This is one of those diagrams. You've probably seen 5 of them throughout this conference and 5,000 throughout your life. Everyone wants to make a new diagram for something. The whole goal is it's a big cycle that you just try to go through, right? Again and again, you'd go through this cycle to refine the work that you're doing and evaluate that process and continue to build on it and produce effective results. So the cycle starts with direction. This is the intelligence cycle, foundational thing, whatever. It starts with planning and direction. So you're going to define the requirements and policy priorities, right? What do we need to know? What do we need to know? That's the bottom line, honestly. It doesn't get much deeper than that. You structure it from there. After that, you're going to start thinking about the collection. You're gathering the information, logs, open source stuff, threat feeds, interviews, whatever it's going to be that you're pulling together. And you can take this data that's relevant to the requirements and answer questions that are posed in the correct direction for that initial plan, right? For your initial direction kind of thing. You don't want to just start, okay, let's pull in anything and everything. You're going to end up with a whole mess of data. Processing, that step's super simple. It's, okay, we have this mountain of data. How are we going to clean it, organize it, enrich it, and kind of structure it in a way that's usable for us? What format is that? What's it going to look like? At the end of the day, this is all about what's the easy use for this data, from an analysis perspective, and how can we turn this into something that's useful for us? This is probably one of the toughest steps of this entire process for different companies is the processing of the data. It's really easy to get a bunch of stuff in, but it's really hard to make sure that you do that well. So there's a lot of different competing solutions in security space. Nobody's really solved the problem. And certs, SMIFs, threat connectors, threat quotient. There's 100 companies out there doing it, and there's homegrown solutions too. It's hard. It's still just data at this point, though, and it's not yet intelligence. So moving on through the rest of the analysis, obviously that's where the analyst is going to start interpreting that data, trying to derive meaning and produce intelligence outputs. Dissemination, share that finished intelligence with the right people, right? Get it into the hands of the people that need it, your SOC analyst, your management, whoever the end goal is there. And it can take many different forms from, reports to just simple lists or dashboards or whatever you be. And feedback is a very important step that some people like to skip. And that's where you sit there and you sit down with the SOC analyst that got that list, you sit down with the management who are reading that report, and you make sure that they're actually getting value from it, and where you're missing the, missing the goal, missing the target, you get feedback on what you need to do to improve next time so you can make this more useful and more effective going forward. The last thing you want to do is just sit here and be this machine that turns out, frustrating to use or broken or incomplete intelligence that people sit there and go, okay, what are we wasting time on this for? It's like a broken record, they never change, they never work with us. So that's the intelligence cycle. That's kind of the first basic thing. The other last basic thing for cyber threat intelligence that we'll kind of talk to so everyone's on the same page and there's not weird references or jargon I'm making are models. So why do we talk about basic models in cyber threat intelligence? Well, it comes down to understanding. It's about understanding the mindset of a cyber threat intelligence analyst and how they try to communicate what they are seeing. Models are just an attempt to kind of standardize it. Not that we've done very well in the industry, honestly. I mean, just look at the naming taxonomy problems alone. We're a whole mess of different opinions and different stances there. But models are a way for them to try and communicate better. So you step through models, and you kind of approach it in that way. So that way, no matter who's in the room, who's reading your intelligence report, it's in a standardized way that they can kind of process and understand it. So this is one of my favorite quotes from Scott Roberts. He's my mentor and the person that kind of made me go to cybersecurity, forced me into cybersecurity. I don't know. Without him, I would not be doing cybersecurity. I'd probably be happy living in a blissful world somewhere else on a beach. But he says all models are wrong, some are useful. And that's the truest thing, because people always want to preach, I have the right methodology, I have the right model, this is the perfect, true, and complete, whatever. Choose somewhere in the middle, find something that works for you and for your company and meets your needs, and prioritize it. So these models, these are the what I would call the people who kill people models. They're some of the earliest ones that we saw emerge in cyber threat intelligence and in the general intelligence communities. And one of the big problems we always have in intelligence is we take stuff from the military in cyber threat intelligence, and then we pretend it's ours, and it's this brand new thing we've invented, and we think it's all grand and revolutionary. It's not. It's military people were killing people, and they found out, okay, if we can get through our objectives as fast as possible, we win. If we can, go through our loop as fast as possible, faster than the enemy, the adversary, we win. We thought that was really cool in cybersecurity, so we kind of took them. Cyber kill chain, it's a classic. It's a Lockheed Martin model. That just kind of steps through the 7 stages of cyber attack, from reconnaissance all the way down to your actions on objectives. And the purpose of it is to help defenders identify at which stage of an attack they're detecting it and where it can be stopped, kind of thing, right? So if you're spotting an attack for the first time or most frequently down at command and control, well, you probably have some visibility or detection problems earlier on. And the quicker you can stop an attack, obviously, the better it is for your organization. There's also the other side of the coin where sometimes you want to let an adversary kind of play through an attack so you understand a little bit about what their threat model looks like, what their tactics and techniques are going to be as they go through your organization. So as far as small teams go, why do we care? It's a convenient way that people like to map threats to the different phases of the kill chain. It's reflected in MITRE ATT&CK and different things like that. So it can help you kind of highlight defensive gaps. It's not perfect. It's another model. But you can go, hey, we caught threat X at delivery stage, and people understand, oh, I know what that means. I know where that happened. So Diamond model, another one that provides a simple, powerful way for people to kind of analyze intrusions. This moved more towards instances and campaigns where you're kind of looking at a cluster of activity. It's a really simple thing where you could just kind of use it to help frame and piece together the puzzle. You have adversaries and victims, and opposing the other side, you have the capability and the infrastructure, so how that attack or what you witnessed took place. And it can help you do a little bit of edge analysis to connect the dots there. So it's a relationship-based model, and it helps you just kind of find those links and then break it down. So it's really good for incidents analysis, not great for a lot of long-term stuff, because with every incident, someone might change their infrastructure with their capability, what malware is used, what backdoor dropper, whatever it may be. It's not super, I guess it doesn't stretch a lot larger than campaigns and incidents. So probably the most popular one that you see a lot of industry people using and moving towards and talking about is the TTPs, right? MITRE ATT&CK, TTPs, tactics, techniques, procedures. They throw it in every report. They make a heat map. They do whatever they want to do with it. That helps people go, okay, once again, what phase is it in? What kind of happened? What kind of sub-techniques? We're talking the same language here about what we're seeing in our environment. So it's a super cool and super important database. MITRE does a lot of good work for trying to standardize things. Bless their hearts. They're up against a really difficult situation there. But small teams can use this to kind of map that observed activity from adversaries or indicators or different techniques and help them identify who you might be facing, what kind of attack pattern you might be up against, anticipate kind of the next moves or what's going on in your vertical in your industry, and kind of interpret that. You're seeing a bunch of PowerShell scripts downloading payloads. You can map it to X technique, understand that, okay, it's under execution. Who else is dealing with this right now? What are they seeing? Who's been on the other side? Who's catching it earlier? What are they doing to find that activity? So those are kind of the easy frameworks that people use to communicate analyst to analyst and kind of share intelligence so people know what we're talking about. Now, moving beyond all the basic stuff, let's talk about the lifeblood of intelligence on a budget. For small organizations, open source intelligence is hands down, it's it, right? It's OSINT, baby. We love OSINT. And it's just publicly available information. That's what open source intelligence is. And when you analyze it, you can yield valuable threat intelligence. So small team's best friend, it's free or low cost in most cases and very abundant. Think threat research blogs, vendor reports, social media, dark web forums, vulnerability databases, malware repositories. The list goes on. And it's just a gold mine of intel that can be tapped if you do it efficiently and effectively, right? 69% of CTI teams, including the big dogs, everyone at the top, they use open feeds in their analysis. They're kind of keeping a finger on the pulse of cultural topography, geopolitics activity, as well as just what are other people seeing and reporting. And it helps them kind of see stuff that's not happening actively within their own environment. And it's kind of that equalizer for us as a small team. It helps narrow that gap. It's one of those big chunks that when you do it right and you do it effectively, it's going to help you really make a lot of progress fast in being such a young team. So key is knowing where to look and how to filter the true signal from all the noise. So there's lots of OSINT data out there. Please don't just start downloading reports and things off the internet and hoping to figure it out later and piece it together and somehow make actionable intelligence and then go to your boss with that. Would not recommend. It's probably going to be a terrible way to approach your situation there at first. Just focus on the requirements, right? Don't drown the data. Focus on the requirements. Use your intelligence requirements to kind of guide that collection and find pieces that matters. Like if you're a fintech startup, prioritize OSINT on threats relevant to financial services, right? Relevant CVEs, threat actor groups, targeting finance, whatever's out there. That's the information you're pulling first. That's what you're interested in. And from that, start to build a curated source list. Sources you can trust, they're reliable, and they're good resources and feeds. Industry, ISACs, bulletins, open certs, whatever you can find out there, bring them together and start having those sources collected so you know what to be monitoring and watching for. Worst thing you can do is lose something, read something, think it's important, and then just tuck it away and expect to remember it later. You're going to have so much brain rot after your 50th, whatever intelligence report of the week that you're reading. Just track it, start from the beginning, it makes it much easier. There's a bunch of tools you can use. There's a lot of free tools. Use the free ones to automate the collection, and like Spiderfoot or Maltego Community, or if you're doing like internet map, use like Shodan, use Google Dork for all I care to find reports. Use easy ways to start getting this data all kind of aggregated and brought together, and start tracking it. But once you're kind of getting all that mapped out and you're ready to go from there, you need to be worried about the quality of the data, right? It's very easy to flood yourself with a lot of garbage data, and then you're doing a lot of sifting. It's much easier to be selective up front in what data you're starting to pull in. That way you're not spending a lot of time, wasting a lot of time, frankly, parsing data that's not useful. So, use case example, there's a suspicious domain that appears in your firewall logs. Just you have that domain appearing, you can go out and OSINT it, right? Go out and look against, Virus Total or Open Threat Exchange reports, DNS, different people that are reporting it, see if anyone has put it out in a recent thing to understand, this is tied to a known phishing kit, right? Easy freebie stuff. You don't have to go and do the research yourself to try and figure that out. If somebody's already put it out there and given you the answer, you see multiple people reporting the same thing, it's much easier to get to that deterministic answer for yourself. Crowdsourcing intelligence, super, super important. Just get involved with the intelligence communities. There's a lot of intelligence communities that share threat intel. It's kind of like a fight club kind of thing. You don't talk about it, but there's people across multiple organizations, and when they see something and it's a trusted group, they just put out like a little advisory like, hey, don't share this out, but watch out for these sets of IPs. Watch out for this kind of activity. We're seeing this kind of stuff. Super, super nice and super easy to get plugged into that kind of thing as like a, hey, trust me, bro, something's going on here. You want to check it out. So get ingrained into that. Validate and enrich your stuff. Not all OSINT is equal, not even close. There's a lot of misinformation out there, so just make sure you cross-verify very critical info before you're making decisions. Enrich your raw indicators with context. Make sure that you're just ensuring that it's quality intel. Get rid of false positives, especially if you're getting ready to start handing this off to management or a SOC analyst, like the finished intel phase. So those are important things. Stay mindful of bias, obviously. There's stuff you should be watching out for. But all of this is important tradecraft as you're starting to drag in the heaps of never-ending data that we call the internet, right? There's so much out there you can tap into. Be cautious, be selective, and you'll quickly see the result or the results of your efforts with open source intelligence. Now, rather than spending your days doing open source intelligence gathering by hand, Googling, looking up, watching the RSS feeds roll in, whatever you're doing to make collections, this is where you start using tools and you start doing things to automate it, right? Especially as a small team. When you're a small team, you're often swamped. You've got other responsibilities. You're juggling this, that, and the other thing. And automation frees up precious time for you to not only do other tasks, but also to focus on the more high-level, intensive, analytical tasks that are required. Like, you're not sitting there manually parsing something. You're not manually downloading it. You can be spending time kind of connecting the dots and doing hybrid-level analysis. So set up automation. It's crucial. Save yourself the time. Save yourself the pain point of just sitting there going through reports. If you don't have a dev, just make an LLM do it for you, right? Like, gaslight them into thinking they're a CTI analyst, and they can write some scraper that's just going to read through a PDF, parse it, and pull out, different indicators, whatever it is. Go online, find any of the free tools you want to do, and start, cobbling together. But focus on automation. Do it for data collection stuff, right? Scripts, APIs, simple stuff to pull data from feeds that are already out there in threat intelligence. This is stuff that's kind of curated. This is like the really free handouts from the companies. Automate your data processing stuff, right? Automate the parsing. Okay, I'm going to have it sit here and watch this feed from X vendor because I like X vendor and they put out quality stuff. every time they push a report out there, I'm going to pull it down and automatically parse it and have the data that I'd go in there and pull out manually ready for me. Enrichment stuff, super important. This is where, all right, we're going to get some information in, whether it's hashes or IPs or whatever it is, and we'll just send that out to an API, some simple services that are going to return some added context information. Is that a known hash associated with malware? Is this a malicious IP that we've seen connected to this kind of campaign, right? You can set up little automations to go and enrich that data. And a lot of these are already bundled into affordable or free tools, right? You do not need expensive SOAR platforms. Just use Python. Like, it's plenty fine, it's super easy. And you can just kind of start setting up this process for yourself. Practical automation, yeah, we've touched on this kind of stuff, right? Threat intelligence feeds, super easy one. IOC triage, that's okay. We have the trusted vendor. We get some IOCs to watch out for. Let's just put those rules into our IPS or IDS to watch out for, or our firewall kind of thing, right? You can just set up a simple pipeline to push that intelligence through when it's something that you're like, okay. We don't need to be worrying about random connections from, is Russia weird here? I know in America it's very weird when I get connections on my home lab from Russia, so like, yeah, simple things like that you don't need to worry about. It's not going to be a false flag. Worst case scenario, you block something that, it's a random bot crawling the internet. So set up simple threat feeds, IOC triage, phishing, if you're going to always be taking that email that's suspicious that somebody reports and putting it into a sandbox for analysis, set up an automation to do it so it kicks back the results for you. So you don't have to sit there and wait for that process every time. Instead, you go, oh, wait, we got a trigger. This is what I'm looking at, right? And all this is already out there. It exists. People have built tools and processes, and a lot of them have free tiers and APIs that you can just use. And they're happy to just let you use and hit. Don't go over your limits, right? But like, use your resources that are out there. They're abundant. So the data pipelines are open, right? We're now moving through this process. You've got data coming in, it's flowing. You now have just a mountain of data that you're looking at. This is still just data, right? Data is not intelligence. Data is not intelligence. Don't confuse the two. You'll be very sad to think that you're done at this point. I hate that fact, but sad thing is there's still work to be done to make it usable and make it beneficial to your organization. So prioritize through the contextual lens of what's that goal, what's the problem you're trying to solve. Use frameworks to help identify and kind of see, okay, what do we need to be doing? What are we focusing on? And use scalable intel processes to kind of make a lightweight, like a review cycle for this. So maybe daily or weekly or whenever you can, triage some new pieces of intel, whatever it is, information that comes in, something that's flagged, a report that comes out. Do analysis on it, and then make sure you have kind of a regular cycle for, okay, I'm going to actually take this intel, even at the beginning stages when it's a new program, am I actually going to be passing that on to the SOC or putting it into a report for management or something like that. Don't wait until you feel like you have this big flushed out program that works really well, this smooth-oiled machine to start acting on and giving intel to people. Give it early on and get feedback early on what you're doing so you can be improving that process throughout. Intelligent requirements, MITRE ATT&CK mapping. So this is kind of like making sure that those frameworks match. This is something that's very common for people to do is, okay, we're starting to see a lot of this kind of activity in our network. We're starting to map it to common threat intelligence stuff. It's helpful for orgs as you process these incidents or even just OSINT stuff. You're marking what's being observed in your industry, in your vertical, stuff to look out for. It also helps you pinpoint and harden defenses in places where you might be missing stuff. Like if one of these columns, like defense evasion, is just completely empty, maybe you have a problem with your visibility in that sector, right? So kind of heat mapping out what you're already doing. You're kind of standardizing your attack surface. It really helps you break down and understand, okay, what's the purpose? The so wet test for each piece of intel you're asking. So what does this mean for us? If it's not immediately clear, dig deeper or just deprioritize it. Maybe it's not relevant information, something that you need to use. You can spend a lot of time in cyber threat intelligence reading about really cool, fancy Chinese hackers or whatever APT you want. That's not necessarily going to be good use of time, and it's not going to help your organization. You need to prioritize what you're up against, what you're facing, and kind of make sure that you're staying on top of that and aware of what you're doing. So Keep using the frameworks, keep using the methodologies, but don't get lost in the purpose or the aspirations of like, I'm doing cyber threat intelligence. I am the new, CrowdStrike. I'm going to come out here. We're going to start producing reports. It's going to be fantastic. Don't outpace yourself. Make sure that you're still staying there and meeting, your management, your stakeholders' needs and concerns. Don't forget about collaboration, right? We said collaboration is super important. CTI is a team sport. If you're just sitting there in your own little bubble thinking you've solved your work problems, you don't have to deal with anybody else for the rest of your time at that company, you're wrong. You should be interfacing with them more than ever before, making sure that you're on the same page, you're communicating what you're seeing, and kind of helping them out. Vulnerability management, your SOC, your IR team, whatever it is, make sure that you're kind of stepping through with them what you've got, and going back to your management for that continued buy-in, right? At this point, they've probably given you the little lifeline, the little resources, the time that you need to be doing this. If you can come back at this point and be giving them proof and evidence of value added to the company and the help that you're doing within the organization, it's very likely you're going to continue to receive support, and it's going to increase your capability. So it's a very rewarding cycle. External collaboration is something a lot of people don't talk about, but I mean, it's right up there on the dissemination phase. You can also be sharing that information jointly with others. There's lots of communities that are just general information sharing communities for threat intelligence, people that are a lot of small organizations that kind of team up and they just share what they're seeing and communicate that for the strength in numbers effect, right? They may not be a company with 100 different analysts working, but across 100 companies, they have a very good team that's able to do that. So join those communities. They're open source, they're easy. Learn about reciprocity. Like when you're working with somebody else, maybe it's even your direct competitor. They're probably a really good person. I mean, your marketing teams may not see eye to eye, your sales team or whatever, but if you can work together to understand, hey, we're both in the same sector, what are you guys seeing over there? Are you getting hit? If you guys get hit by a certain kind of attack and they're coming for you, maybe you share that information with them, help them understand what you're seeing so they can better inform their defenses, right? You guys are probably going to be targeted by the same kind of threat actors. You're facing the same kind of difficulties. So work together outside of your own organization to kind of multiply your efforts and be a bigger team than you are. So moving on beyond all of that, why do we choose a CTI platform? Well, honestly, it's because as your intel collection grows, you kind of need a place to store it, to organize it, and to analyze it. And your brain is just never going to be enough. Your brain is going to break. It will not be able to handle the sheer amount of intel you do, especially if you're automating all your collection and bringing in just heaps of data. So there's a few key players that we're highlighting here. MIST, it's been around forever. Okay, it's a very established platform. It was really built around sharing IOCs with other people. OpenCTI, it's the newer, kind of sleeker, modern platform. It's got a cool interface, graph database stuff, and it was built to model more complex threat data using sticks and kind of taxi stuff. So that's fun. And then the final one is Synapse. For me, this one's powerful. It's a central intelligence system, and it's gained a lot of traction for its very flexible capabilities. It's very powerful. It's a little less famous than the other two, but for me, it's a game changer. So we're going to jump into these, think about the different data models, their community support, different platforms, kind of see which one might be a good fit for you. But ultimately, you're going to need somewhere to start putting this data, and a Google Doc of Death or an Excel sheet is not going to be the answer that you want to do to be storing all this data that you're pulling in. So the quick and dirty on MIST. It's widely used, it's open source, it's focused on IOC sharing collaboration, right? It's originally developed for sharing malware indicators, and a lot of certs and ISACs and different people use it. They have their own threat model, so the strengths are it's simple to use, and has a lot of support for it. Trade-off-wise, I mean, it's kind of old. The user experience is not very good. It's powerful, but it's very complex to configure to your needs. And scale considerations, there's a lot of moving parts here. Less than OpenCTI, but it just needs a lot more to kind of scale up and be bigger. So organizations need a robust, IOC management system. Pretty good. It has a lot of nice integrations. Beyond that, you might want to look past it. OpenCTI, this was the new kid on the block. It uses new data models that are more depth than what MIST uses. So it's more rich data modeling. It's got a nicer UI, frankly, more customizable, easier to kind of fit to your needs. And it has a lot of also integrations and connectors that have kind of been built out by the community to help out. As far as trade-offs go, though, it's quite complex to deploy. It can get quite difficult, especially if you're not a DevOps engineer or don't have those kind of resources on hand. And it's powerful. The graph approach that they take is powerful, but it is also hardware intensive. So there's more overhead to running this, especially at scale when you're pulling in large amounts of data. So last one, Synapse, right? Open source central intelligence system, Vertex project. Really cool people that came out of Mandiant and built a similar platform. And it's got a highly flexible data model. So it's not just limited in the way that it has different schemas. Rather, the cyber threat intelligence you ingest in whatever form it comes in, you're able to kind of tag it and link it together in these complex relationships, which allow really natural analysis for humans. You can use their query language to kind of dig into that data and punch through it and understand it really well. So it's super powerful. It's got amazing integration and really amazing automation stuff built in, stuff they call power-ups that kind of enable you to be a superhuman. Trade-off with it is, it's a steeper learning curve. It's not as simple as some of the other ones, and it's not been around as long. They have a really good supportive Slack community and stuff like that behind it, but it is a little more complex, and the nice user interface and everything you get with it, it's paywalled. It's the enterprise version. The open source version is free, but it's all in the terminal. Not that I think that scares anyone here, but you just have to be a little more complex or comfortable using stuff that's not built for around a GUI. So Synapse is the amazing choice. I mean, long story short, if you want a broad view of threats with a nice UI, OpenCTI gives you a lot. If you're really into having complex intel needs, or you want something that's going to scale well with time, and you're willing to invest a little bit more in learning up front, Synapse is going to be that big payoff, and it works well for that. So as I'm running up on time, we're going to jump through a bunch of this. This is more me preaching about Synapse and how amazing it is. I'm totally not actually working for Synapse. This was a joke about, use my link to get a kickback. I'd love to be paid by them at some point. But Synapse is really cool. It's really powerful. We're just going to speed run through these. But I mean, you can see you can ingest anything. This is just a random cyber threat intelligence report. It goes through, it auto-extracts, the different groups, who's putting out the report. It tags the date. It tags different malware, different sets of activity, all that kind of stuff for you, and kind of starts pulling it out into these lists, which then it can go through and run all these different, scripts against that. It's going to go through and we're going to check for, all these different hashes. We're going to go all the stuff you'd probably do yourself when you're looking at something suspicious and going, what the heck am I looking at? Go figure, somebody probably's automated it and put it into a nice, cute little tool like this to do it for you, because we're not lazy, we're efficient, and we love it. Go through cool graphs, understand pivots. It has a lot of good data stuff behind it. And it, at the end of the day, can help you produce reports just nice and automated, because the worst thing you want to do is try and go, okay, what have I been looking at for the past month? The big wig in the C-suite wants to know, I got to make some important report for this guy and get it out to him. So Synapse is a super slick solution. They've got a lot of support and demos. So I've built a few what I would call scrappy, shoestring budget kind of CTI programs for a few different places and help them out with that. And I mean, really, it comes down to you lay down the groundwork with people. You're not going to have anything at the start with some of these places, no fancy tools, nothing. And you have to kind of figure out what are the quick wins, what are the visibility that we can bring for them. After that, what's the tooling up we can do, processes, automation, stuff like that we can bring to them for cheap, right? And make sure you're putting things in place that scale well or are easy to, kind of Lego together and switch out different bricks as you go along through that process. So it's super important. Just start with the people, start with the processes, then worry about the tools, right? Make sure you kind of get your head on straight. Get those success metrics out early and make sure you're meeting them. Do your best to kind of return that value to the company and the stakeholders and people that are around you. And, be cautious about what you're doing. Be pragmatic. You're just a one-man team a lot of the times, or a very small team. Don't get kind of over-ambitious about what you're doing there. So as far as closing out, I don't know if we have time for questions. I was going to take questions, probably not. So final thoughts kind of thing is just remember, Maybe I lost it. Nope. Yeah. So just leverage what's free at hand. Make sure that you're building an incremental process as you go through this, right? Use your frameworks. Use stuff that's common in the industry that people have put out there so you stay organized. You don't want to make this a burden or a hassle for yourself or for anyone else at your organization. At the end of the day, this is supposed to be a value add and something that's enriching and beneficial. So invest in that automation wisely and be very intentional about it. Wow, I put that in there twice. Anyways, so start small, grow forward and grow, all the good things. I'm Chandler McClellan. Thank you once again for having me out here. It's been amazing.
Thank you, man. That was great.
Thank you.
Fantastic talk, I thought. Lots to think about there. And unfortunately, we don't really have time for questions. Went over just a little bit there, and we do need to start tearing down before the venue kicks us all out. But I'm sure you can find Chandler afterwards to answer questions. Perfect. So to start off the closing ceremony, Jesper?
Continue talking, man.
Do I have to vamp again?
Yeah, vamp about the weather.
No.
Honking.
Do you have oh shit, you got a presentation for that?
No, we have some slides. But okay, let's start though. You can't see me, which is a cool thing because you've seen me a lot. So let's start our round of thank yous.
Yeah, let's do it.
So can we get the Chalmers CTF team? Chalmers CTF team, do you say that? The organizer of the CTF, Chagu. Can you come on stage,
yes,
please?
Please come on stage, all of you. Wow, there's a lot of you.
It is a lot of you.
I'm going to jump off so people can see them. Wow, well, I guess it takes a whole village to build a great CTF.
Can I say just a few words?
Yes, please.
Hopefully, we will do this again next year, and I wanted to point out some very specific people. Please, go to the front. Mateus, go to the front. Jesper, where the fuck are you? Go to the front.
Here?
These amazing three people and Talha, our other communicators person, who is very tired, are looking for jobs, will be soon on the market. Look for them.
Yeah.
Do I get 500 kroners? 500, anyone?
All right. Amazing work, guys. Thank you so much.
Thank you so much.
All right. Give them a round of applause, guys.
And so I think we should...
I mean, they're...
come clean.
Right. We really couldn't do this just on our own.
I know you think that we're doing this alone.
Yeah, and that we do it with only the money we get from your ticket sales. But unfortunately, that's not true.
Exactly.
So we would like to please and warmly thank all of our wonderful sponsors that make this possible. You've been great. You're all participating in this event in such a great way and make it a lot more fun for all of us.
Yeah, we really had a tear-dropping moment, me and Johan, last night before dinner, because we were so happy that we see so many young people here at our venue. And the sponsors actually helps us do that, because we can't really afford to do a lot of student tickets, because it's really expensive what we're doing. Our sponsors are helping us bringing new blood into the community and bringing the community together. And we all in this room are responsible for that, which we are very, very thankful for. So for us, everyone here, thank you.
I would also like to take a moment just to thank all of our fantastic speakers. You've all been magical.
Yeah.
It's been great. Every single talk has been interesting, and I think I've seen almost all of them.
Yep.
So give yourselves a warm round of applause, and everyone else can join in too. Amazing. And we're not going to keep you much longer, but it's not just me and Jesper running this show.
Exactly.
We're just the, the clowns
We're just
on
the
stage.
gestures, right? The clowns. So there is a lot of people behind the scenes. So we would like everyone.
Yeah, please.
From the
everyone
from the crew.
not everyone in the room. That would be the
That
stage
would be
is big,
cool,
but not that big.
But everyone from the Security Fest crew, get up on stage.
Yeah.
We need
Please.
you. Everyone.
We're not worthy.
Yeah, exactly. So this is actually the wonderful people that worked really, really hard to make this event happening, which we are really grateful for. And yeah, thank you so much.
Yeah, thank you
did
guys.
Very, very,
amazing
very
job, as always.
Yeah.
And yeah, I think that's it from all of us.
Yep.
That's the end of Security Fest 2025. But we will, sorry? Oh, well, I'm getting to that.
Yeah, okay.
We're just going to, you know, take a bow. Actually, all right, let's switch it around. First of all, thank you to all of you, all the lovely participants who came and made this wonderful with all of us. So give yourselves a round of applause. Yeah. Good shout. And now that's it for Security Fest 2025, but we will return next year bigger and better than ever.
Yeah, and if you have a suggestion on Village or some shenanigans that we should do, don't be afraid to chat out. We will help you out.
Yeah.
So do that. If you have something cool that we should do or improve,
reach
we
out.
want to know. Reach
Hello
out.
at securityfest.com.
Exactly.
Do read those emails.
Benjamin will read all of them.
All right.
Thank you.